Okay. Good morning, everybody. Welcome. Welcome to the SEE meeting, and it will start with this tutorial on IPv6, mostly on OpenWRT. I will explain later what this super convoluted title with many acronyms means, what all the acronyms mean. But before, let me introduce myself. My name is Ondřej Caletka. I work for Reimagining Learning and Development. We are taking care of the training courses and e-learning and certification that we are doing for you as the RIPE community or as Reimagining members. We are also actually having a training course that will follow this SEE meeting on Wednesday, Thursday, and Friday. So, well, you are very welcome to join us there if you are not registered yet. In this tutorial, I will just explain what the IPv6 mostly concept is and how you can run it at home, which might be something that you might be interested to try technologies on your own. I will do some live demos, so it will be quite interactive. If you have any questions during, please ask straight away. I think the question etiquette is here that you should go in the middle to that microphone, so the question is recorded. So there will be like some windows for questions, but if you have something in between, just come here and ask it straight away. Okay, let's then begin with this IPv6 mostly. What exactly it means? When we talk about IPv6, our usual idea of IPv6 is dual stack. We even used to, this is actually, on the right-hand side, this is actually a picture from our training courses, and we even used to say that the best transition mechanism to IPv6 is dual stack. Why? Because, you just have IPv4 like you had before, and you just add IPv6 next to it. They more or less don't know about each other, so they are not interacting with each other, so they cannot break, one cannot break the other. Well, and then, of course, if you have broken v6 and working v4, this is something that was so common that the operating system vendors and web browsers vendors have created algorithm called happy eyeballs, which is basically masking problems with IPv6. The only issue here, and even though it's the only issue, it's quite fundamental issue, is that, by deploying dual stack, you are not going to solve the fundamental issue why IPv6 was designed in the first place, and that is, we don't have enough IPv4 addresses. If you have dual stack, you still have to have everything IPv4. So by deploying IPv6 next to it, you still have this. You still need the same amount of IPv4 addresses. Fortunately, there are other transition mechanisms which are, let's say, less demanding on IPv4 addresses, and one of the very popular is called NAT64. And in a nutshell, what it does is that you translate between IPv6 and IPv4 in a way that you basically can have your end host, in this case this laptop on the picture, only running IPv6, and either it's connecting to other IPv6 hosts on the internet directly, or it's going via a translator that will make IPv4 out of IPv6. And with DNS64, which is a trick with DNS, which is trying to pretend that every single host on the internet has IPv6 address, it works very well. There are some small issues which I will go in detail a little bit later, but it works. It is used very often with mobile networks. So mobile networks deploying v6 are usually doing v6 only, and they use NAT64 to access for v4 addresses. And to make it work fully, they actually use concept that is called 464xLAT, which is yet another extension of this NAT64, basically with another translator that is inside the end device in this case, and this another translator takes care of all the legacy applications on the computers that we still use, so those legacy applications still think that there is fully working IPv4, because there's like, they see like dual stack, they see like if there was IPv4 and IPv6. Yeah, I'm just going very briefly through this because just to put it into somehow into picture. I will go much more detailed when we get to the hands-on part. The point here is that, well, the question you can ask, if I run my network only v6 only, can my device work on it? And the answer is, it depends. And it depends a lot on the device itself or its operating system, to be precise. So in the first category, we have all the devices from Apple plus Android. And these, because as I said, mobile networks are really running IPv6 only networks for a long time already in their networks. And mobile network operators have quite a big influence on features of mobile phones or mobile operating system, because yeah, they are selling it, so they can ask for the features. These are supporting IPv6 only networks flawlessly. Then we have the second category, yeah, and it's because there's this CLAT, there's this translator, and as I said, mobile networks are doing it. Then we have the second category, and they are like desktop computers with either Windows or Linux. In that case, you can run IPv6 only. Well, I have been doing it at home for like last maybe 13 years or so. So yeah, it works. It works for, let's say, 95% of use cases, but chances are that maybe your particular use case will not be covered because there is no CLAT, this extra translator is not present there. So if you have an application that is really emitting packets, emitting IPv4 packets going to some IPv4 addresses, and there is no IPv4 address on your computer nor default route for IPv4, then obviously such application will be broken. And the third way, that's the sad story, what you can also plug into your network is something that I just call IoT or smart home. And of course, like there's this like very huge category of various gadgets that have somehow internet connectivity. The most common factor of them is that either they don't support IPv6 at all, or if they do, they still require the network to have a working DHCP-v4 server. And if there is no DHCP-v4, they will just say that, well, DHCP doesn't work, therefore internet doesn't work. It's similar also, game consoles tend to do this thing. So, well, there's not really help for them. If you want to run these devices, you somehow have to have IPv4 in your network. Which brings us to this, yeah, I have also another diagram to illustrate this problem. So basically on the left is how it used to be in the past. We had just one network protocol that was IPv4, and everything was connected over IPv4, and everything worked. Except that we run out of IP addresses, which make this IPv4 not really future-proof and sustainable, and therefore we have this solution called IPv6, and that's the situation on the right-hand side, where basically we have just one protocol that is called IPv6, and we can reach everything. Unfortunately, nobody did this transition, so we are somewhere in the middle. And of course, the obvious way of doing this in the middle is what I just talked about, and that is dual stack. So you just keep your IPv4 and you will add IPv6 next to it, and you will just but then you're essentially running two networks. You haven't solved the issue with lack of IPv4 addresses at all, but at least you are sort of getting ready for the ideal future world that is on the right-hand side. From the other side, you can do this IPv6 only network with NAT64, where, as you can see, you can get rid of IPv4 in most of your network infrastructure. Most of your infrastructure can be v6 only, and then you have just a small, tiny piece of v4 that is taking care of this residual connection. Unfortunately, as I said, not everything will work. There will be some brokenness, and that is exactly where we get this IPv6 mostly, which is sort of like a bridge between these two proposals, between dual stack and IPv6 only. So it is an IPv6 only network for devices that are known to support IPv6 only operation, but at the same time there is still native IPv4 available in that network for devices that are just not capable of running on v6 only. So this way you might be able to get let's say to the state where you will not save all the IPv4 resources, but you will also not use IPv4 address for every single new device, even though such a device would be capable of running on v6 only. So that was just like a brief introduction on this concept, and now we are going to, let's say, do it for real. And so this is my starting scenario where we start from. Of course, in order to talk about running like v6 at home, there's this fundamental requirement that you have to have v6 at home. If your ISP does not provide you with IPv6, yeah, then you can probably get some sort of tunneling, but that would definitely not be the most efficient way that you can have IPv6, and it's probably like then out of question. But let's say your home network has IPv4 and IPv6 connectivity, you have everything dual stack, and you would really like to gradually get rid of IPv4, so you either can see the things that are going to break, so you can eventually fix them or at least be ready, or yeah, you are just curious like me, and you want to see how it works and how useful it is. So in order to run everything, well, you need a device at home, and in this case, I have really good experience with operating system that is called OpenWRT, which is an operating system specially designed for, let's say, home routers, CPEs. It's a Linux-based operating system that you have complete freedom of configuring it. So I can recommend, I have actually 2 tips for hardware here. I'm from Czech Republic, and also one thing that is from Czech Republic is called Turis router, which are quite expensive, but also very nice metal routers running operating system called Turis OS, which is basically a fork of OpenWRT. But if you want to stay on a budget, another device that you can buy very cheap, like for 50 euros, is this thing that I have here with me. It's from GLINet, and it's also a device that can be comes with firmware that is based on OpenWRT, but can be easily replaced with vanilla OpenWRT, which is what I did. And of course, you have to have a dual stack upstream connectivity with IPv4, IPv6, and also with delegated space. That means you have also IPv6 not only on the link between your router and the upstream router, but also for your devices in your local network. So I have a few steps here. What we are going to do, first of all, we are going to create another LAN network that will be IPv6 only. And we will just, so basically we have the main network that will stay dual stack, and we will put IPv6 only network next to it. Then we will set up this translator NAT64 using a tool called Joule. We will set up pref64, which is necessary for everyone to know that we are running the NAT64. Then we adjust the DHCP server to do IPv6 only preferred, which is basically when we create the IPv6 mostly network. And in the end, we will talk about DNS64 and how to automate such a setup in case you are doing it regularly, like me, for instance, when I always like start from the scratch and configure this thing up again. So without further ado, let's start with the IPv6 only networks. Also, Dave, I didn't mention it, but there will be some breaks here. And in those breaks, because there's a Wi-Fi in this, and I will tell you a password for that Wi-Fi in a moment, and then you can check on your own device whether you can connect to this network, how does it work for you, and so on. So first of all, what we are going to do, let's keep the default network that is called LAN, and this is the default network from OpenWRT as a dual stack, and we will instead create another network which is called LAN 6, which will be just like LAN but without any IPv4 config. There are several options how to configure things on OpenWRT. One of them, let's say my most favorite, is just the textual config files that you can see in these gray rectangles over there, where there are different parts of the configuration that you can set up manually. But well, there is also a web interface which I'm going to try to show you just right now. Yes, hopefully it will get visible. Let's make it a little bit bigger. No. So first of all, let's do some cross-check whether everything works as it should. So this is the web interface of my router that is here on the desk. I also run this website called doesnotwork.eu, which is a server that does not work over IPv4. So the fact that I can reach it means that my IPv6 connectivity is working. I'm cheating here a little bit because, yeah, it's usually quite tricky to get proper IPv6 connectivity from a venue, so it's actually a tunnel that is going somewhere else. But I have IPv4 and IPv6 connectivity here, so all the prerequisites are fulfilled. So now I can show you how. Yeah, you can see that there's a WAN port here. There's a LAN 1 port where my computer is connected to. And I can then show you how quite easy and straightforward is it also to do it in the web interface. So I will start with just going to the interfaces. Here I see what interface I have. So I have LAN interface, and I have one interface here, and there are some other interfaces which are like not that important. And there is also like devices. So basically there is this concept of high-level interface is like the layer 3 device that is like where you set up IP addressing and things as such. And underneath it, there's like a layer 2 device which is called device. That's something like bridge. There's something like VLANs. There's something like basically lower level stuff. So here I'm going to first add a network bridge, and the bridge will be called BR LAN 6. Oh, shoot. Yeah, I just pressed escape. So BR-LAN 6. I will just add port LAN 2 into it. I have to also remove it from the other bridge. I want also empty bridge to be brought up. And I think that's everything I need to set up here. So the bridge is there. I also will remove port LAN 2 from the other bridge, so the port is not in two bridges at the same time. That would not work well. So now I have a bridge device here, and now I can create the interface here. Again, add new interface. The interface will be called LAN 6. It would have a static address because it will be like a upstream interface, and it will use the device BR LAN 6. I will just create it. And in this case, I'm not configuring any IPv4 address, but I'm not even configuring any IPv6 address. Why I'm not doing it? Because with home connection, usually everything is dynamic. So setting up static IPv6 address might not work well if your upstream ISP decides to renumber your network, which they sometimes do. Sometimes they do it very often, sometimes they do it only once in a while or never. Instead, in advanced settings, somewhere here, I actually say IPv6 assignment length, and I will just decide that I want a prefix of a size of /60 assigned to this device. And I can even, because I like some nice numbers, I can even say assignment hint saying 60, that means that I want this prefix to contain 60 somewhere in it. So that's just like, you know, hinting, telling the router which prefix it should select. So then, of course, I also need to put it into some firewall zone. So it's a LAN interface. So I'm going to put it into LAN zone. This should allow me to use it normally. And DHCP server. Well, the section here says DHCP server, but it's actually also about other forms of auto configuration. So I don't want any DHCP server because I want it to be v6 only, but I do want to have a router advertisement on it, which is on this tab of IPv6 settings. And here I just say that I want arrays in a server mode. And I also want DHCP v6 because why not? The rest, I think I can just stay like this. I press save. Nothing happened so far, but because there are like unsafe changes here. Here I can actually review whether what I did with my clicking makes sense. I hope so. I'm not going to review it now, but I just press save and apply and hope for the best. Now the network will restart, reconfigure, and if I'm successful, okay, I'm not yet successful, apparently, because I don't see any IPv6 address on the LAN 6 interface. And I know why is this the case, because I also need to restart the WAN interface, because the WAN interface is the interface that is assigning IPv6 addresses to the downstream interfaces only when it's started. So hopefully this helped. Let's see if I refresh this. Look, now there is already an IPv6 address. I hope you can read it. Maybe I can make it a little bit bigger. So, yes. As I said, I was hinting the router that I want to be the number 60 to be somewhere. So the somewhere is actually here. And also you might be wondering why I'm setting up a subnet of a size /60. That is quite unusual. Usually, like, you know, subnets are /64. That's one very cool feature, I would say, of OpenWRT. And that is that if you assign a bigger range than /64 to an interface, it will also work as a DHCP server with prefix delegation for possible downstream routers. So you might take another router, plug it into LAN port of your router, and it will still get some IPv6 prefix for devices behind that second router. So that's why if I'm not in the, if I don't have very small assignment from my upstream ISP, I rather put /60 instead of /64 to every single interface, so I can even accommodate some downstream routers. Now, and if I did everything right, we should have the LAN 6 network, which should be on Wi-Fi, but should be also on a wire. So let me just plug myself into the other port that I have here. Let me just open the terminal. Actually, you know, this is the second time I'm delivering this tutorial. And when I was doing it a few years ago in Rome, the thing that people get like the most from the tutorial was actually if they are using Mac OS, like I do here, that there is this command called ipconfig, which people are not aware, and it's very cool. So I'm going to show you right now. I just don't know how to make it bigger. I can make it smaller, so that's not exactly what I wanted. Yes, this is okay. And so my Ethernet is, what's wrong? Ifconfig, en. Yes, I start with ifconfig. Everybody knows ifconfig, of course. So here you can see that there is like some IP address, which sounds good. There is no v4 address, which is expected on the v6 only network. And the command that people are not aware is called ipconfig, where you can do things like get RA en7. And if I just do this, the macOS will tell me what the router advertisement it received on this interface and what was inside that router advertisement. So you probably know that router advertisements are used for configuring IPv6 on your network, and I can see here that there is basically this prefix information /64, there is this root information 4/48, there is this RDNSS option, so this is the DNS server, and there is also another option that this macOS does not understand. So it seems to be working. Let's test with my doesnotwork.eu web page. If I just refresh it, yeah, you can see that it still works, so IPv6 works, but you can see also that it says that IPv4 does not work. So we have a working internet. So let's just type internet into internet. You can see that like Google works. It just found internet. I can click on the Wikipedia link. It also works. So it's not that bad actually, except that maybe if I just go and click some link a little bit further down, I will just get this error, and I will just think, oh, they probably have outage on this web server. It actually happened to me a few times that I just click on some result from Google and I just got this outage, and I was thinking, oh, there is an outage, and then this website just doesn't load properly, there is CSS missing, so they probably have also some outage. But if you click a few more links and they would have also outages, oh, this one works, then you would think like, oh, maybe something is wrong with my internet. So yeah, like Odi.nl, for instance, it's like, or Google Ad Services in this case, it just doesn't work. So that is the reason why we still need IPv4 somehow to be able to run the internet. Anyway, let me go back to my slides. So what we have now, so basically we have the two networks. Dual stack network is business as usual. We didn't do anything with that. And we have this new IPv6 only network where there is no IPv4 support. So this is the ideal future internet. This is the rightmost picture that we had on this graph before. You can see that a lot of things already work there. I can do Google search, I can go to YouTube, I can go to Facebook, what I also did there, yeah. But also there are many things that do not work. So this is the first like stopping point for you if you want to give it a try. There's also Wi-Fi. There are two Wi-Fi SSIDs. One is called IPv6-only, one is called IPv6-mostly. Both of them have password of tutorial. You can also scan the QR code to connect to them. And you can see on your own device how this IPv6 only network, or in this case the IPv6 only network, the one in the middle, is the one that is like important, because the other one is still like normal dual stack. So you can see on your own device how it works for you, whether it's usable or not. Any questions so far? All right. So we have to make it a little bit more usable. And we make it a little bit more usable by putting in something called NAT64. So NAT64 is a piece of, let's say, software in this case, which has this role of pretending that everything is reachable over IPv6, even though if it's not true. So it's basically a packet translator that translates IPv6 into IPv4 and vice versa, of course, because the traffic is bidirectional. There are several flavors of NAT64, so you can have like a stateless NAT64 or you can have stateful. Stateless NAT64 is mostly used on the, let's say, server side. If you want to run IPv6 only server farm, but you still want to allow IPv4 only clients to reach your services, you can just put a stateless NAT64 in front of your server farm and just translate all the incoming IPv4 traffic into IPv6 traffic, and then the opposite translation on the way back. This is not our case. In our case, we have like IPv6 only clients, and we want this group of IPv6 only clients to share some limited amount of IPv4 IPv4 addresses that would be used to reach IPv4 only services. So here we need some state that would help us to basically not to do one-to-one mapping, because if we mapped every single IPv6 address to one single IPv4 addresses, we would just not have enough IPv4 addresses. So we have to do some kind of address sharing, just like a normal NAT on IPv4 does, that probably everybody here is familiar with. With NAT64, one thing that you need when you are configuring it is which IPv6 prefix will be used for translating into IPv4. And there are basically two options. One is called well-known prefix, which is 64:FF9B. We will use this one in this demo. Or the other option is network-specific prefix, which means basically any prefix that is like your own can be used for NAT64. Important rule that is written in the RFCs, and that some platforms are enforcing while others do not, but you cannot really rely on it, is that it is forbidden to use a private IPv4 addresses inside well-known prefix. So basically, if you use well-known prefix and you would like to map address that is like 10.0.0 something, such address should not be translated into well-known prefix. And some implementations of NAT64 or CLAT are enforcing it, so basically they will drop packets that are trying to reach to these private networks. Others are just passing it through normally. So if you, that's like a forward reference. If you figure out that something works nicely on Android but doesn't work on macOS, it's probably just because you are trying to reach private v4 address using well-known prefix, which works on Android and doesn't on macOS. How we do this in NAT64? There is one project that is very like useful and powerful and well-known. This is called Joule. It's developed by originally developed by Nick in Mexico, Nick.mx. It is packaged for OpenWRT, so we have it quite simple just by installing the right package. Even though it's not really integrated into OpenWRT and it's not really easy to implement it, they're like straightforward. So basically, I invent some trick that I will just show you right now. What's the issue with NAT64? Basically, the issue is that the data structure in Linux kernel are more or less like separate for IPv4 and IPv6. So it's not easy to change packet from IPv4 to IPv6 somewhere on the way through the data structures inside Linux kernel. So what Joule does is that basically it's stealing packets that are supposed to be translated in the pre-routing, which is like very early when it enters the machine, and then it translates it, and then it will just inject translated packet to the post-routing, which is like very late. So it's basically completely bypassing things like firewall and similar thing in Linux kernel. So if you want to have some firewall rules, this is quite hard, and also as a side effect of this, the translation doesn't work for traffic that is originated on the machine itself, because the machine itself originated traffic doesn't go via pre-routing, so it's not stolen. So that's why my proposal to how to use it to make it simple and straightforward is to make use of this nice feature of Linux that is called namespaces. And in this case, basically, we will use a separate network namespace, which is something like you probably heard about containers, like Docker or so. Network namespace is just like containers, but only for network interfaces. So you can run a process and this process will see completely different set of interfaces, completely different routing table, but everything else will be the same. It can touch the same file system. It can do everything the same. And this is very handy for us because we just can keep the main namespace where our normal router is, as it is, and we will just connect a virtual Ethernet part between Mary namespace and Joule namespace, where we will do the translation. So basically, our router that is in the middle will just act like a router, and whenever it wants to translate something, it will just send it via a new interface to the Joule namespace. Joule namespace will take care of translating it and return back the V4 address, which will be again routed by our router as usual, as it was normal user traffic. It sounds quite complex and convoluted, but actually it's pretty simple. So there's a shell script that sets everything like this, and it fits on the slide, and we just install those 4 packages, and if we do everything right, that should be it. So I'm going to do it just right now. So in this case, I'm going to do it on in the CLI, because it would probably not be that easy to do it on web interface if we want to just edit files. So I will just start a file that I will call setup Joule sh, and I will just copy paste the contents of the slide. Oh yeah. The only thing is, if I knew how to do drag and drop. Yes, it's here. So I also need to install the packages. So let's do OpenWRT update. This will synchronize the list of packages from the internet. And then I just do OpenWRT install kmod veth ip-full kmod Joule net filter and Joule 2 net filter. Hopefully no typos. Hopefully internet works. Yes, something is downloading. Something is happening. Oh yeah, and so now I can probably just run this setup Joule. Yeah, of course I should make it runnable, or just do sh. Something happened. It seems to be like doing something. If I just look at the list of interfaces here, I should see the interface called Joule, but it's down, of course, because now I have to configure it also on the OpenWRT side. I just did something outside of OpenWRT, so there's just new interface that appeared there, and I also need to, so they actually have it on the next slide. So I need to configure it on the OpenWRT site, and I will do it just like another LAN network. Like I did the LAN 6 network, I will just create a new LAN network which will have this IPv4 subnet of like whatever I just chose. In order to make it simple, I'm actually going to do double NAT. So all the IPv4 traffic will be NATed again in my OpenWRT, because that's the most easier way to do it. We will also allocate 1/64 to that network with Slack on, and this will help us, the translator, to have these IPv6 connectivity, and then we will route all the NAT64 prefix into it. And we have to not to forget on firewall, because if we don't put it into firewall zone, it will just be, the packets will be dropped. The easier way, that's like a philosophical question, whether you consider your translator part of your LAN network or part of your WAN network. In my case, I just put it into LAN zone, and I consider everything translating happening there, which is easier because in LAN zone in general, all the networks are allowed to talk to each other. So I'm going to do this. I'm going to just copy these things and put it into the config files. So I need to set up the DHCP config into the DHCP. Let's copy this and let's just edit the etc etc config DHCP. So I will just create the DHCP for Joule. I will do the network where I put just the interface config for Joule, which is here. And just as I said, I need to also put it into firewall zone. So I will just put it into zone that is called LAN. I will just put Joule here. And now I just need to restart everything properly. That is always the tricky part. Let's see if just restarting network will help. Of course, restarting network while being connected to network is always a little bit like, yeah, not that nice thing, because now I just keep pressing enter and hoping that it will come back. Which is not happening. Did I just lost it? Yeah. Okay, let's try again. But at least I can log in again. That's a good sign. Let's see if this restart was enough. If we look here, okay, Joule has some addresses. That's a good sign. So I have another slide for this. Let's just show it. How do you test whether your translator works? Well, you can use this interesting, also not very well-known feature of IPv6 addressing, and that is that the last 32 bits of IPv6 address can be written just like IPv4 address. So you just take your favorite IPv4 address and put 64FF9B, which is the NAT64 prefix, in front of it, and if you ping it, and if it responds to ping, that means that that the translator is working. So I'm going to do it right now. 64 FF9B : favorite IP address for me, for instance, 1111. And yeah, of course, there's some issue with UTF, and if I accidentally press accented character on my keyboard, it will just break, but in the end it's pinging, which means that the translator is working well. I should also do one more thing, and that is I'm going to do the same ping from my computer here. So let me open another window. Okay, this is macOS, so I have to do ping 6 for IPv6 ping. But yeah, if it works even from my computer, that means that all the firewall rules are set up properly, everything is working. Yeah, that's what my slide here is saying. So we have NAT64, that's great. But if I tried let's say my testing website here, does not work.eu, you can see that it will not change, because my computer have no way how to figure out that there is NAT64 in this network. It could be somehow probing the well-known prefix, but as I said, well-known prefix is just one option of deploying it. So my computer still doesn't know anything about how it can reach IPv4 address. So if I just put, let's say, address literal into my browser 1.1.1.1, it will be just unreachable. If I do this trick, and I will instead put here like 64:FF9B : 1111, it will work. I will just get this scary warning from Cloudflare that direct IP access is not allowed, but it will work. So you can see that this is just an application layer issue. It's not a network issue. So the network part works. So now we just need to somehow tell our computer to use this, to put this 64FF9B in front of every IPv4 address. And we do this by using this pref64 option. So pref64 option is yet another option in the router advertisement. We already saw the router advertisement. We saw that there is like prefix, there is like routing information, there is DNS information, and now we can also put another option that would be carrying the NAT64 prefix. And just by the device receiving this NAT64 prefix, it will figure out, okay, that means there's IPv4 translator on running in this prefix, and I can send all the IPv4 traffic to that v6 prefix, and it will just work. This is a new feature of OpenWRT that was released in 2023. It was a patch that I written for then somewhere in 2022, and it was just sitting there for a year, and then finally it got merged. So I'm very happy that now, and the developers actually made me even do the web interface part for it, which was in the end not that hard, and it's also quite straightforward. So now I'm going to show you how easy it is to enable this pref64 on an interface. So I just click edit here in the interface, and here in IPv6 RA settings, there is just this NAT64 prefix where I just fill in the placeholder value and save it, and that's it. I will do the same thing also for the LAN network, which is here. So I just go to DHCP server, IPv6 RA settings, and here I just put this thing. Yeah, it's not really visible, but the value that is there is now like placeholder. The form field is empty. It's just like the placeholder is actually the same prefix that I'm going to do it, so I'm just going to replace this gray text with black text. Save. Again, I just save it here, but these changes are still unsaved. You can see it here. These are the changes that are going to happen when I press save and apply. So I press save and apply. The network will restart. And now it will be the good time to run the ipconfig command again. So I just run ipconfig get RA en7. And you can see here that now there is pref64 option here, which is here. And if you also do ifconfig now, en7, you can also see that that my macOS has immediately reacted to that root advertisement, and it created this new line here saying NAT64 prefix, where it figured out what the prefix is, and it created another address that is called CLAT446, which is the translation prefix. So my computer, and also it created this fake address 192.0.0.2, which is like IPv4 address. So my computer immediately figured out that now, okay, I can use this thing, and therefore now if I open my browser and I go back again and type 1.1.1.1, it will just redirect me to 1.1.1.1 in words. I can also show you that I just do ping 1.1.1.1, and it just works. So basically, because my computer is in the leftmost group of that where everything works, it basically just activated this translator that is translating the IPv4 traffic into IPv6, which goes to the router that translates back to IPv4 and go further to the internet. So in the end, everything works like there was native IPv4, but there is no IPv4 on the wire between my computer and my router. So yeah, that was this straightforward, and I think this is exactly the time where we will just break this, because we have a coffee break of 30 minutes, if I'm not mistaken. Let me double check the schedule. At 11, there should be coffee break until 11:30, and then we have yet another hour. So I will keep it on this slide, and you can use this coffee break not only to refresh yourself, but also to go and try the networks that we have now set up here. So what we have now, we have an IPv6 only network, the QR code in the middle, that should work completely normally with Android or iOS or macOS, and it should work barely with other OSs, because like Windows or Linux, they don't have support for pref64, so they will not figure out there is NAT64 in this network, so they will just continue like seeing only IPv6 operation. On the other hand, the network that is named IPv6 mostly on the right-hand side is just still running dual stack, and there's business as usual, so it should be quite boring. Yes, and with that, thank you for being here for the first time. I wonder how many of you will be here still after the break. That's like a gauge for me how interesting this topic is. And then so see you at 10:30. Thank you. Okay, I see almost as many faces as I saw before the break, so I count this as a success. And let's continue. So, just to recap what we did already, we set up an IPv6 only network. There was no support for NAT64 for IPv4 at all, and it worked barely. Then we set up this NAT64, and we set up this option pref64 to tell the compatible devices like macOS or Apple or Android phones that there is NAT64, and from now on it works completely normally. The IPv6 only network is working completely normally with Android or with iOS or with macOS and with other OSs, which unfortunately I don't have with me, but maybe if you have it with you, you can try. It doesn't work at all. Well, IPv6 works there, but IPv4 doesn't work at all because it cannot read the pref64 option from the router advertisement, and therefore IPv4 is just dropped. Anyway, we can just, now we will just step a little bit aside. So we now have IPv6 only network that is like completely usable for some devices, like those Androids and iOS, macOS. But if we take these devices and connect it to our other network that is called IPv6 mostly, it will just work as well, but it will just consume extra IPv4 address. So now what we are going to basically do is to focus on the other network and change it from normal dual stack network into IPv6 mostly. How we do it? We do it with this DHCP option that is called IPv6 only preferred. It's DHCP option for DHCP version 4, so the DHCP that is used for configuring IPv4 networks. And in this case, the DHCP is not used to configure an IPv4 address, but is used to not configure IPv4 address, which sounds a little bit silly, but it's actually quite clever. So let's just look how DHCP works. As you know, DHCP has clients and servers, and it's basically done by exchange of 4 messages. So it starts with discover. Every time a client connects to a network, it will send a discover message, and in this discover, it will just list the parameters that the client is interested, like default gateway, DNS information, routing information, and so on. It can also add another request, and that is requesting option number 108. And 108 is basically the numeric value of this option called IPv4 only preferred. Because IPv4 only preferred are 3 words, and 108 is just like less words. Well, actually, it's also 3 words, but shorter. People just call it 108 usually because it's faster. And just by the fact that the host, the client in this case, will just request parameter 108, it means that the client is basically saying, even though I'm asking for IPv4 address, I can actually live without it. So if this network supports IPv6 only operation, I don't need to use IPv4 at all. In this case, the network apparently doesn't support IPv6 only operation, so the DHCP server will just ignore the request for option number 108 and just send back offer for IP with IPv4 address, netmask, gateway, DNS, and so on. Therefore, the client will just continue. The client will just send a request, say that, okay, I would like to have this address, which the DHCP server will acknowledge, and this is how the IPv4 address gets configured. So this is the situation where, let's say, your Android phone or your laptop or your MacBook or your iPhone is connecting to some Wi-Fi network, let's say the Wi-Fi network in this hotel, which is IPv4 only. This is exactly what is going to happen there, what is happening there, and you can see that in the end it's just normal DHCP handshake. Now the trick is, if such a client, which is requesting option number 108, will connect to a network where the DHCP server is configured, that particular network is capable of running IPv6 only operation. In this case, the DHCP server will react to the request of option 108 by offering an option 108 in the offer of the IPv4 address. And the value of this 108 parameter would be timeout for how long IPv4 should be suspended. So let's say our server will just send back offer saying, oh, you are asking for IPv6 only preferred, and I'm just offering you, yes, you can do IPv6 only for 30 minutes. And this is the information that the DHCP client wants to know, because the DHCP client will figure out, oh, that means that I don't need IPv4 to operate on this network, so I will just stop here. So the client will stop, it will not finish the transaction. Therefore, the IP address, the IPv4 address that is offered to the client will expire quite soon because it's not requested, and it will not be occupied, it will not be used. And after that timeout, after those 30 minutes, the client will retry. So basically, every 30 minutes, the client will repeat this same handshake, asking, discover, and getting back information. No, wait another 30 minutes. This way, basically, the network can be dynamically reconfigured, let's say, from IPv6 mostly to dual stack. So the point here is that basically the device can will do DHCP discovery, so it will work for all network. But if the network supports a v6 only operation, even though the device is trying to do DHCP, it will do DHCP, but at the end it will not get an IPv4 address. Interesting thing about this DHCP option 108 is that there's really no need to do something special, because as long as your DHCP server supports custom options, which most DHCP servers support because it's used for various things like provisioning of access points, of IP phones, or things like that. You just create custom option with number 108, and with the timeout, you can do it in OpenWRT by just specifying the DHCP option like this. You just encode the timeout yourself. It has to be a 4 octet long number, so I just put there like 708 in hex, which is 30 minutes. And that would be it. So before I do, let me just plug into the other network, the one where we have dual stack. So let's just clean this. I will just reconnect my cable to the other LAN port and look at the ifconfig en7. Yeah, so far you can see that now there is everything. So you can see now that there is native IPv4 address, this one. So now I'm running in a dual stack. Another ipconfig command that you can use is called getPacket. So if I do ipconfig getPacket en7, it will just show me the DHCPv4 packet that I received that was used to configuring my device. So here you can see that, that I was offered the address to 192.168.211.232 with a gateway of .1, and yeah, router information, domain name, servers, all these basically DHCP option. I can see it here. This is again like very handy feature if you have only a MacBook and you are trying to troubleshoot why the network doesn't work. So ipconfig get packet will show you what DHCP offer your computer got. And I'm showing it right now because once I change the configuration, which I'm going to do just right now, let me go to the interfaces, LAN, and here in DHCP server, I go to general setting, and somewhere here, no, advanced setting, somewhere here is DHCP options. And here I just put the DHCP option 108 with the value of 0078, which would be 708 hex seconds of delay. And I just save it. I only do it in the LAN network because it's the only network that is running DHCP v4. The other network is IPv6 only, so it doesn't make any difference. So I just add it, I just save and apply it. And now I probably need to replug my cable to see, let's see if, yeah, it's still there. So of course, I restarted the router part, but the computer didn't figure out that the DHCP server is now providing something different. So in order to speed this up, it will probably happen when the IPv4 address would expire and it would do reloads, but I just speed it up by unplugging and replugging the cable. And now you can see that there is no IPv4 address anymore. And instead of there is this IPv4 address 192.0.0.2, which is the translator address. So now the CLAT got activated and the IPv4 is going via the translator. I can also double check by using this get packet, which will just show empty output. That means DHCP didn't succeed, basically, because it didn't continue. It didn't get to the final point because this computer is honoring the option 108. So that's basically it. I can also do some, let's say, standard check by going to doesnotwork.eu. I can see that I have both v4, v6. I can also try going to 1.1.1.1. Oh, if I was able to type correctly, of course. And it will just work. So you can see that I have basically fully working dual stack, but my computer is only emitting IPv6 packets, and they are being translated in the translator. So that was quite easy, straightforward. And what we have now, what's the difference? Well, we didn't change the IPv6 only network, so there's the same thing as we had like just a few minutes before. But we did change now our dual stack network. Now the dual stack network that we have is not dual stack anymore. It's IPv6 mostly. So it still works like a dual stack for Windows or Linux, which are not using this DHCP option 108, so they will just get normal IPv4 address and they will just use dual stack. But for all devices like Android or Apple macOS or iOS, it will just work just like the IPv6 only network, so there will be no difference. It will just use only IPv6 address and it will use the translator for translating the to reaching the v4. So, are we done already? Or almost? There's still one thing that is a little bit controversial, maybe, because it's about faking DNS. And of course, faking something is always troublesome. But here we have a good intention. We are faking DNS in order to make the network work better. So that's the point of DNS 6.4, and it's a little bit older approach than what we had before. So as we did before, we set up NAT 6.4 and nothing happened because the devices didn't know that they are supposed to use NAT 6.4. So in order to tell them to use NAT 6.4, what we did was we added the Pref 6.4 option to the router advertisement. So now the devices know that there is NAT 6.4. But of course, this requires cooperation from the device side, that the devices have to pick up this option and set up something on their own side accordingly. DNS6.4 was invented before, and it was trying to avoid all this by basically tricking machines that everything works via v6 because of DNS. So basically, how does it work? First of all, the easy part is, for native IPv6, there is no change. So if you do DNS query for a service that is already supporting IPv6, you will just get the IPv6 address through, and there's nothing changed. What changes if you query for a domain name that only has IPv4 address attached to it and no IPv6 address? In this case, the DNS resolver will figure out that you basically, if you are requesting v6 address for that particular name, it will just create a synthesized answer which will contain the NAT64 prefix and the IPv4 address that was resolved using a query. So in the end, when using DNS6.4, you will basically get every single domain name on the internet will have IPv6 support, either natively, that's the best part, or it will be synthesized by the DNS6.4. So basically your DNS6.4 resolver will be faking answers for you, pretending that every single host has an IPv6 address, which means that on your host site, on your computer, you don't have to do anything. You basically connect to IPv6 address, and like it's an implementation detail whether this IPv6 connection is actual native IPv6 connection end-to-end, or whether there's a translator somewhere on the path which is translating this IPv6 address to IPv4 address, because that endpoint on the other end is just IPv6 only. It works very well. I already told this a little bit. It works very well, but it has an issue. It has an issue, for instance, with IPv4 literal. Of course, this whole thing relies on DNS. So if you don't use DNS and you just type address directly, it cannot work. It also has issue with DNSSEC validation, because of course we are faking DNS. DNSSEC is technology to prevent faking of DNS records. So these two technologies are like inherently incompatible. And then of course the other issue that we still have on some computers is that, yeah, we are running software that was programmed in 1990s when there was no IPv6, and the software is just emitting IPv4 packets. So even if it uses DNS, it does not query for quad A record because it cannot create IPv6 packets. It can only create IPv4 packets. So in this case, yeah, these issues cannot be solved, but on the other hand, the majority of today's usage of internet will just work. Let's say your web browser will work very well with DNS6.4 without any issue. Now the question is, do we really need a DNS6.4? Because eventually it will be probably superseded by this pref6.4 option on the root advertisement and the in-host translation that we just did. On Android, it can just work with NAT6.4 and pref6.4 without DNS6.4. There's this crossed out sentence which was true for some like 3 version back old version of iOS and macOS, which is now crossed out because it has been fixed by Apple. So basically, today's devices can work very well with just without DNS6.4. On the other hand, DNS6.4 makes makes even the legacy OSs use more NAT6.4 and less native IPv4, which means that maybe we can then remove even more IPv4 from our network. So I would say DNS6.4 is definitely good for a network that is IPv6 only, and it's a little bit less good for IPv6 mostly network where those native devices have also native IPv4 available, because if you run DNS6.4 and if you have also native IPv4, the thing is that most operating systems are preferring IPv6 path over IPv4 path. So it will actually prefer the DNS6.4 synthesized IPv6 destination over the native v4 destination, which means that it will force the traffic via NAT64 instead of going directly natively. So in that sense, it might not be the best thing. But I would say for the IPv6 network where there is never any native IPv4 path, the DNS64 can help. However, it's a little bit tricky to set up. So there are a few options. The first and the easiest one is to use some public DNS64 services. So you probably know Google Public DNS, the very well known for 8s, and also Cloudflare Public DNS, very well known for 1s. They both also run public DNS64, which are not running on that fancy addresses, but still they can be memorized with some effort. The only thing is that if you want to use public DNS64 service, the only option for you is to use well-known prefix 64FF9B, because that's what they do basically. They translate every IPv4 only resource into well-known prefix and the IP address. Yeah, but maybe I would say usually people that are running OpenWRT and their home router and fiddling with things like this, they are usually not very happy with depending on third-party public resolver. So let's see what other options we have. This is specific for Tourist OS, which are these fancy Czech routers. One of the things because they are produced by CZNIC, and CZNIC is a company that is also developing NOT-DNS resolver. They just decided that the default resolver there would be NOT-DNS resolver, and therefore you can, and NOT-DNS resolver has support for DNS64, so you can just configure it with this. There's some like example here. And this way you can just make it if your router is Tourist OS. However, if you run OpenWRT, it's not that easy. But what you can do and what is already made in the packages of OpenWRT is that you replace DNSMask, which is the DNS resolver that is used in OpenWRT normally. You can replace it with Unbound, which is a DNS resolver from NLNet Labs. And this Unbound will make it possible to turn on DNS64. There are some small caveats that I wrote here, like that if you do it the easy way, you might lose local DHCP host names in your DNS. But there's a solution for it. There's this link on the bottom right of the slide. So if you download the slide and click on that link, there's some explanation how to do it. It's also tricky in a way that DNSMask is not only DNS resolver, but it's also DHCP server. And we still want to use it for DHCP server, so we cannot just stop the DNS mask. We just have to change its DNS port to 0 to turn off DNS feature and keep the DHCP feature. To make things even more complicated, when you do this, the DNS mask will stop offering DHCP option with DNS servers, which is option number 6. But you can easily fix it by adding DHCP option number 6 like this, which is also visible on the slide. Yes, so let's try to do it. We still have some time because we are slowly getting to the end of this, and then there will be some Q&A. So if you have some questions, or if you think you might have some questions, just you can prepare them in the meantime, while I will try to install Unbound here, and hopefully, well, if my SSH will connect, this usually helps. Yes. Okay. So I'll just install Unbound. Except that it's not called Unbound. No, I'm already root. It will not help. Sudo doesn't help with missing packages. It's not. It can help with lots of stuff, but I'm just thinking that there should be something unbound dash something like unbound daemon. Okay. Now, the only thing is I should know how to spell this. And for the third try, something is happening. By the way, yeah, some of these things are quite resource hungry regarding the storage space. So if you are buying a new router for OpenWRT, it's actually a good idea to look at the flash size and also RAM size, because some of the home routers, in order to make them very cheap, they are very, very small in this, and then you might not fit all the packages you would like to. In this case, you can see that it's quite okay. I have 128 megabytes of flash apparently, and I'm using 6.5 megabytes. So it's like, that's like in the old days where the computers were still small. Anyway, so I have this Unbound installed. What I'm going to do first is I'm going to go to DHCP config, which is also DNS mask config, and I will just remove the DNS service from the DNS mask, which will be done by option port set to 0. I also have to fix this DNS option by putting the DHCP option with number 6, which is the DNS server, and I will just share the DNS server option 0000, which does not mean that the DHCP server will be offering DNS server of 0000. It will not make sense. It's a special value that the the DNS mask will figure out that it means I should announce my own address as DNS server. So this is the modification of the DNS mask. I think I can just restart it. DNS mask, restart. Yeah, it will do some sanity check. And now I can try, if I do some ping, it should probably just fail because now I shouldn't have working DNS. Yeah, it's just saying bad address because now the DNS doesn't work. Now I essentially broke my computer, my internet. So let's just fix it by going to at the etc config unbound, but not vim. Okay, vim, which is actually vi, I think. There's already DNS 6.4 here and DNS 6.4 prefix, so I only need to flip this from 0 to 1 to enable DNS 6.4. But of course, if I'm running unbound, well, this is something like, let's say, off topic from this presentation, but if I'm already running unbound on my localhost, I will just not let it forward queries just like this. I will enable DNSSEC validation because, yeah, that's the first point of having unbound somewhere. So I just end because running open DNS resolvers is not a good idea, especially not on home routers. There's actually some safety mechanism here, which means that you just set up the interfaces that the unbound should listen, and it's in the list called interface LAN. And I just tell him that my LAN is not only interface LAN, which is the default, but it's also interface called LAN 6. So I basically have to list all the LAN interfaces here because there is some magic in the starting script of the unbound that is basically generating a config file for unbound so that it just doesn't create an insecure configuration that would contribute to this brokenness of internet and DDoS attacks and things like that. And you can see that the Chrome already figured out that DNS started working. I have working this thing. I can also try ping here. It works. The question is now, does it also work for, does also the DNS 6.4 thing work? That's easy way how to check it out. Let's just ping some domain name that we know that is IPv4 only. Do you have any idea of IPv4 only domain name? GitHub.com. Yes, that's very famous. And you can see that it actually pings, and it pings over v6, and you can see that we are pinging this address that is basically the v6, NAT64 prefix, and this is the IP address of GitHub that is just written in hex. So if you convert it to decimal, it would be standard IP address that we all know. So we can see that DNS 6.4 now works. I'm here on my Mac, and on my Mac everything worked even before, so there is virtually no difference. I cannot show you any difference in this sense. But if you have, let's say, if you have Windows or Linux and you connect to the IPv6 only network, it should now work with only very minor issues. So you should be able to browse the internet, read your mail, do those things without any issue. Maybe if you start virtual machines and the virtual machine expect that you have native IPv4, that one will break. But like for general usage of the internet, it will just work because DNS 6.4 will take care that every thing will be available over just v6, even without the translator. For the other devices like Android or Apple devices, it will just work normally like 100%. And the same thing would be in this IPv6 mostly network. I have a side note here about these issues, and actually I lost my thread now, but hopefully I will find it back. What I wanted to say, it was something about these issues that you have or not have. Hopefully it will come back. Let's get back to slides. The last bullet point here, and that is something that, yeah, it might not be as useful for you as it for me, and is that, yeah, if you maybe want to play with your network and then put it back into some reasonable state, maybe you want to automate all this configuration. So Ansible is the typical tool for automating things. Unfortunately, like, there's no Python in OpenWRT by default, and there is no native Ansible support for the configuration system that the OpenWRT is using, which is called UCI. However, both of these issues have been resolved by this role that is like available on GitHub. So I created some roles that are usable for configuring basically everything that I just was talking about today. There are several steps, like starting from LAN 6, then setting up Joule, setting up Pref64, DHCP option 108, and finally Unbound. All these roles are there on this repository. I just tested yesterday whether it still works with the current version of OpenWRT, and yes, it does. And I just, so this way you can basically get this working setup of IPv6 mostly from a completely freshly fleshed router in a few minutes. Yes, so that's more or less the hands-on part. I still have some more information because this topic is a little bit hot, and there's like the development is ongoing. So first of all, I already told that this IPv6 mostly, or basically, I'm talking about IPv6 mostly, but what we actually want to see is not IPv6 mostly, is the support for IPv6 only operations, so we don't have to use native IPv4. And it's already supported very well in Android, in Apple devices, both macOS and iOS. And it's getting even better because last year, Windows basically promised that they will implement translator CLAT into Windows 11 in some future version of Windows 11. So that would make Windows join the club of devices where everything would work nicely. However, there's no timeline for this. And regarding Linux, it's also not that bad there because there is at least one person who is now actively trying to create implementation of translator of CLAT in Network Manager. And there is this open merge request and issue in the somewhere in the issue tracker of Network Manager, and the developers are participating. And hopefully, fingers crossed, this will end up in some time. You know, it can be months, it can be year or two, that even Linux machines using Network Manager will support IPv6 only operation, which will make it very efficient, much more efficient than it is already now. And here I have this screenshot from RIPE 88, which was last year in May in Krakow. And there I was just like, I was just doing this quiz. I was asking people, hey, we now have 527 people, devices connected to the Wi-Fi. How many active DHCP leases we have for this? And people were like putting some tips there. And funny enough, the one that got least answers was actually the correct one, because we had 527 devices connected to the Wi-Fi, and we had only 85 leases out of the HCP pool. And that's because basically only Windows machines and Linux machines were taking the IPv4 addresses. The rest of devices, which of course depends on the venue, but you know, everybody now has a mobile phone, which is a smartphone, and that's one device connected to Wi-Fi usually. And yeah, of course, this might be a little biased that RIPE and CC's employees all have MacBooks, so it's like another, can be different. But in general, like there's at least 70% of devices on each network that are already very happy with running just with v6. And if Windows and Linux will join the club of the devices that are happy to run in just v6, we will easily get to the point where basically the number of devices using IPv4 is just negligible. So my point here is that IPv6 mostly is this new concept where you have this network that supports everything, and it's sort of like yeah, gives IPv4 to those old devices that need it, but at the same time does not give it to new devices. But I still feel like this is just temporary, and this can be easily, this is basically the bridge that is bridging us from doing dual stack as we did before, this IPv6 mostly was a thing, to doing finally IPv6 only. Because if we now already have 70%, and if we, in a year, if you have like 95% of devices running IPv6 only on a network, then I think, you know, the amount of disappointment of people, if we just turn off v4 and just those 5% of users might have some small issues, will probably be a reasonable thing to do. So, yeah, dual stack was supposed to be temporary. That's the thing, you know. When IPv6 was invented, it was expected that the whole internet will switch to IPv6 at some point in time, except that point haven't happened for the last 25 years or so. We are somehow stuck with dual stack, and we got used to the safety net of IPv4 everywhere. But this is not sustainable. We just don't have the addresses. They're just not there, and they will not be there, and there's no way how to get more addresses there. So this IPv6 mostly allowed us to save a lot of addresses. Once more operating system will join, it will be completely reasonable to get rid of v4, which means that our IPv6 mostly will become IPv6 only. Yes, and that's everything I had This is my email address and my website where you can find this presentation as well. Oh, actually, I didn't publish it yet, but in a moment, after I finish here, it will be there. And now it's the time, if you have any question, comments, or anything that you would like to ask, feel free to, ideally if you go in the middle and ask on the microphone so it's part of the recording. Don't be shy. I am pretty sure not everything was clear, but of course the slides, you can go through them again. Oh yeah, one thing I forgot to tell you is that we are, well, it's sort of obvious from this slide, but we are running this in the RIPE meeting network since RIPE 85. So RIPE meeting, yeah, it's usually, we have like a peak of 700 devices. And as you can see, most of the devices are just not using v4 anymore since we deployed it. We still have some issue. And now I just remember what I wanted to say here. So I'm going to say it. Yes, I'm saying here that it works without issues on Android, iOS, and macOS. It's mostly true. It is without issues, as far as I know, on Android and iOS. On macOS, however, there can be issue. And can you guess which type of software have the most issues with the computer running IPv6 only? Actually, it's VPNs, especially those VPNs is quite a wide term, but most of the commercial VPNs that are used either to bypass geo-blocking or to make your internet more secure, which is complete wrong, but yeah, and never mind. The thing is, unlike on mobile operating systems, let's say like Android or iOS, where the operating system is quite locked and there is only limited sets of things that applications can do, including the VPN applications. So even if the VPN is IPv4 only, it still works nicely on iOS or Android because it just gets the IPv4 only VPN will get translated to IPv6 before leaving the phone. So there's just like extra layer of translation, but it works. In case of macOS, there is no like, well, it's not mandatory to use VPN API on macOS. Actually, the VPN clients are running with root privileges, so it can do whatever it wants. And usually, those VPNs that are used for like your extra protection, they have this feature called block IPv6 bypass of VPN, because they consider IPv6 not like internet technology, they consider it bypassing, because basically since their own VPN product is v4 only, if somebody has dual stack, they can go through VPN via v4, but if they go via v6, it's bypassing the VPN. So in order to prevent this, most of these VPN solutions are now equipped with something called IPv6 kill switch. So basically it will somehow modify the operating system to not to emit any IPv6 packets once the VPN is on. So what happened, and I saw it last RIPE meeting, is that you connect to network, everything works. Then you turn on the VPN, this VPN client. The VPN client will establish the connection. The connection will get established over v4 via the translator in the computer, over v6 on the wire to the other end. And once the VPN is up, the kill switch for IPv6 gets activated, but it will kill the connection to the VPN. So the VPN will get dead. So then basically, and this way, like there's no way out of it. So I hope that eventually this will, like VPN vendors will become aware of this issue and figure out how to do this IPv6 bypass without killing IPv6, hopefully by providing v6 natively inside the VPN, which would be the proper thing to do. Oh yeah, that was the extra that I wanted to mention. Let me ask one more time if there's any more questions, comments, feedbacks. Or you can also just find me. I will be here all day. Yes, can you please go to the microphone?
Hello, Svetlana Tanasova. I have a question about modern VPN solutions that are not even layer 3 based anymore, and they act more like application layer gateways, like Zscaler, Netscope, probably Tailscale. What about the interoperability with this type of VPN solutions?
Yeah, let's say I cannot like talk in general, but if you, for instance, say a Tailscale, yeah, it's Tailscale is actually a very good product in a way that it supports IPv6 natively as much as possible. It will also just establish tunnel over the v4. So in general, like as long as there is no this IPv6 kill switch that will basically just kill IPv6, it just works. There might be also small MTU issues, which is always the pain with any tunneling technology. And in case of IPv6 to IPv4 translation, there might be MTU issue, which is like stems from the fact that IPv4 header is just 20 bytes and IPv6 header is 40 bytes. So if you just translate v4 to v6, you will just get 20 extra bytes anyway. So this is something that might trigger some interoperability issues, but in general, like even those modern VPN solutions, they are just okay, as long as they don't try to kill v6.
Actually, I am more familiar with Netscope and Zscaler, and they create network device at kernel level, and they even use carrier-grade NAT IP ranges.
Oh yeah.
That are 100.64.
I would say once you get to the IP address conflict, yeah, that's really hard to do anything about it. Yeah, and also another thing that I got noticed during this testing is that it might be that some VPNs are enforcing remote DNS resolver, which will break the DNS 6.4, of course. So if this relies on DNS 6.4, that's another thing to consider. But again, like DNS 6.4 is sort of like now being obsoleted by the other options, so it's...
And especially with Cloudflare zero trust access, they are also forcing their usage of their DNS.
Yeah, that could be an issue. But as I said, like in general, these devices, like they don't rely on DNS 6.4 anymore because they just use this embedded translator. But yeah, definitely, this is something. So that would be my thing. If you run this thing and you want to deploy it on scale, the thing that you should put extra focus is different VPN solutions. That's like something because that's something very low level in the networking stack, and it can break in many ways.
Okay, thank you.
Thank you very much. Okay, and since I don't see anyone else jumping to the microphone, I think it's, I think we are done here. So, well, if you want, I can still have this thing running here for a few more minutes if you want to give it a try. You can also catch me. I will be here the whole 2 days, and I will also be doing training courses from Wednesday to Friday. So I think you can still sign up on the website of RIPE, of this SEE meeting for the training courses. So if you want to, we can see each other there. That's everything from me, so enjoy the rest of this event, and see you soon. Bye-bye.
Hello, everyone. Hello. Hello. Thank you. My name is Zorz. I'm the chair of the program committee. Welcome to Sofia. It's snowing outside. It's lovely. Yes, we ordered the weather. So let's start this meeting. I'm here on behalf of the program committee. I would like to present you the group of people that brought you the amazing program that we are going to see and hear in the afternoon and tomorrow. So it's Zoran, Božo, Vesna, that is outgoing, sadly, Goran, Ivana, George, Eric, Branimir, Sanel. Then Svetoslav is the local host that is hosting this meeting. Aryan is also back to the program committee. And this is Vladislav and myself as a vice chair and the chair. I would like to ask my PC cats to stand up, please. So these are the PC cats. If you are happy with the program, talk to them or to me. If you are unhappy with the program, talk to them or to me. And tell us how we can do better next time. A little bit of housekeeping for questions, comments, and suggestions. These are just one mic because it's not a big room. Please queue at the mic and state your name and affiliation clearly. Then I would like to thank the RIPE NCC staff for all the work and everything put in this organization of the meeting. And I would like to thank BIX for being a local host. Thank you very, very, very much. With that, I think it's time for the RIPE NCC staff to come. Gergana, please. Thank you.
Thank you, Jan. Здравейте, много се радвам да видя толкова много от вас тук. Hello everyone. Really happy to see so many of you here in Sofia. This is our 13th iteration of the RIPE NCC regional meeting in Southeast Europe. And it's the second time that we're coming back to Sofia. So we have gone through most of the countries, and now we're doing our second iterations, our returns. As Jan already said, I want to thank the host, BIX.BG, for helping us with everything. They have been really an excellent host from anything from logistics to spreading the word in the Bulgarian community. And we're really happy of the continued support. They hosted the SC3 meeting, RIPE SEC regional events, this event, and some events also that we have in our pocket in the future that I hope to be able to share with you very soon. I also want to thank our sponsors. You can see here on the screen, Hilco Internet Society, NetNod, and Flex Optics. They're helping us keep the costs for RIPE NCC manageable. So thank you very much for your support as well. We have quite a lot of staff at the meeting. So here on the slides, you can see their faces. Maybe I can also ask the staff who's here in the room to get up so that people can see you in person. Thank you very much. And some of our staff is currently outside, and I want to encourage all of you to speak to them. That's why we have come here. We want to hear from you. What do you think about our services? What do you think about the RIPE community? Do you have any suggestions for us to do something different, to do something more? This is why we're here. Please talk to us. I also want to mention Mirjam is here, the chair of the RIPE community, and we also have 3 board members, Piotr, Remko, and Sander are here. Same, they want to hear from you, so whether you have a feedback for the RIPE community, whether you have feedback for RIPE NCC services, please approach them and let them know what you think. Jan already presented the program committee. I just want to thank them again for volunteering their time. They do this, for the good of the community. They volunteer their time, so thank you very much again, Jan and the rest, for helping us form such an amazing agenda. I know it's not difficult. I know that it's not easy. It's a difficult job to gather so many interesting presentations, and I think they did a really good job. So thank you very much again for that. Probably you already saw at the registration desk the 3 beautiful ladies. We have Kaja, Sandra, and Hafsa, who have put together a very good event. I'm sorry for the formatting here. And if you have any questions about the logistics, feel free to approach them either here or at the registration desk for that. We also have the RIPE NCC services desk, where we have different departments from our registry pillar represented. If you have any questions, be it about your membership or about your IP resources, feel free to go and talk it directly with them. It can happen much faster when it's in person. Then we also have, for a few years now, we have a code of conduct. The code of conduct is valid for all of our events that we're organizing. And if you notice any behavior that you think is a violation of that code of conduct, please reach out to me or to my colleagues Hisham and Sandra. You can see the email addresses as well on the screen. We would like to help with that. Now, this is a new activity that we're organizing for the first time at SEE 13. The activity is aimed at newcomers, but also returning attendees. For our regional meetings, we have between 30 and 40% of newcomers, so if you think you're the only one, you're not, for sure. Thank you also to Laura for organizing this. The idea is that you might have noticed these fish bowls with little colorful paper inside in the cocktail tables in the coffee break area. If you pick one, depending on the different colors correspond to different interests. If you pick one, you're going to find a question there that is going to serve as a conversation starter. I would like to encourage you to try it out. And here on the next slide, you can see what different interests correspond to different colors. So blue for general ripency, community engagement, and so on. Really try it out as a nice conversation starter, and we would like to see how it works out. The questions are really fun. So do check it out. Lastly, I wanted to let you know about our social events. So later today, we have the dinner. It starts at 9:30, and then if you are staying at the hotel or if you're still around 7 o'clock, between 7 and 7:15, there are going to be shuttle buses to take you to the event. Otherwise, you can find your own way by public transport or taxi. If you don't have the dinner ticket, you can get one at registration desk. And yeah, I hope to see all of you there. And then Tuesday, our second day, we're going to close the conference with a closing plenary. It's going to, with a closing reception, sorry. It's going to take place here in the hotel at the 3rd floor. You don't need a ticket for that. Your badge is enough. So yeah, please join us for that as well. And that's all I had to share. The next speaker, my dear friend Mila from the host, BIX.BG, please come on stage.
Hello, ladies and gentlemen, dear friends. On behalf of the Bulgarian Internet Exchange, welcome to CE13 and to Sofia. For us, it's always a pleasure to work together with the RIPE NCC team to host their events in Bulgaria. If you need any help or information, all of us, we are at your disposal. See you tonight during the dinner, where there will be many surprises. Enjoy your stay in Sofia and have a very nice time. Thank you to be here. I'm happy to have all of you.
Okay, next one is Alun. Please come. And we need from a technical team, can we have a microphone? Thank you.
Hello, everybody. My name's Alun Davies. I'm the RIPE Labs editor over at the RIPE NCC. And today I'm going to be talking about how the internet has been managing to route around cable damage in the Baltic Sea. This is actually my first time presenting at a SEE meeting. It's my first time in Sofia, so I'm very glad to be here. And I would just like to thank the program committee for giving me this great opportunity to come and talk to you about some of the work that we've been doing recently. So if everything goes according to plan over the next half hour, if everything goes according to plan, I should leave you with a pretty good idea of the work that we do at the RIPE NCC, not only to collect internet measurement data and to make that data available to the public through services like RIPE Atlas, but also to look at how we get insights out of that data so that we can better understand what kind of state the internet is in and how different events that happen around the world actually impact the way that the internet operates. So before I get into that, just a couple of things. Like I say, I'm the RIPE Labs editor, so my job at the RIPE NCC is to look after RIPE Labs. We publish content from people all across the internet community, for people in the internet community. We put out new articles every week. We also have a monthly RIPE Labs podcast. We have competitions where you can win tickets to go and take part in the RIPE meetings. So there's a lot going on there. There's a lot of good stuff. If you're not a regular reader already, do go and take a look. One thing that I will note here is that a lot of the material that I'm going to share today follows off the back of 2 articles that we published at the end of 2024. And we also did a podcast episode on this, which went live just last week. So if you want to look into this a bit deeper at the end of the talk, you know where to go. So do take a look. Speaking of that podcast episode, my guest there was Emil Arben. All of the research I'm going to talk about today was led by Emil. This is really his brainchild. So if there are any very technical questions at the end of the talk, I reserve the right to dodge them completely, but I will put you in touch with Emil, and he'll be happy to get into the nitty-gritty with you. So, with all that said, what's been going on in the Baltic Sea? Well, here's a kind of partial timeline of events, really focusing on the events that we were actually had time to analyze. On the 17th and 18th of November, reports emerged that 2 cables in the Baltic Sea had been broken. This was the BCS East-West Interlink cable between Sweden and Lithuania, and also the Sea Lion 1 cable that runs from Finland down to Germany. Both of those cables were then restored within about 10 days after those initial breaks, only for the Sea Lion 1 cable to then be broken again on the 25th of December. And while that has been restored, in the meantime, we then saw another outage on the LVRTC cable, which runs between Sweden and Latvia. So there's a lot going on, and this isn't all of it. And there was a lot of coverage of these events, as you no doubt saw. There was a lot of questions and speculation as to what actually caused them. And just about 3 weeks ago, a month ago, The Guardian put out a really fantastic visual guide that kind of walks you through everything that was happening in the Baltic Sea over the winter. So that's really worth a look if you haven't seen that already. It's really informative. But while, you know, a lot of these organizations are quite rightly asking questions about, you know, what led to all these outages, we're a neutral organization, the RIPE NCC, and this isn't really our job to go asking those kinds of questions. When these kinds of things happen, what we want to know is how they actually affected the internet. So when these first outages occurred, our initial reaction was to go and see if they left any kind of signal in the internet measurement data. And our first protocol there, as usual, was RIPE Atlas. For those of you in the room who maybe haven't seen RIPE Atlas before, this is a system that we created at the RIPE NCC back in 2010, yep. And it's basically a global network of probes. And these are these little devices, typically these are these little devices that you go and plug into your home router or your office router. And they perform internet measurements so that we essentially like get to measure the internet in real time from all these vantage points all across the world. You see the distribution of probes there on the map. At the moment, there are over 13,400 of these devices connected to RIPE Atlas. And I must emphasize that these devices are hooked up by volunteers. We really depend on the goodwill of the community to keep this thing running, and those volunteers looking after their probes. Another important part of RIPE Atlas, and this will come in to what I have to say as I carry on, are the RIPE Atlas anchors. And these are essentially just like kind of beefed up probes that are typically located in data centers and places like that. So they provide this really reliable source and destination for RIPE Atlas measurements. And just to give you some idea of the scale of all this, there are about 35,000 measurements performed every day on RIPE Atlas on average. That's looking at last year's figures. But the bit that I want to draw your attention to here is a part of RIPE Atlas that we call the anchor mesh. So just like the probes, RIPE Atlas anchors perform a whole bunch of different kinds of measurements, ping measurements, DNS measurements, traceroute measurements, and so on. But the really cool thing about the anchors is that about every 4 minutes, every anchor in the system pings every other anchor. And this is great because it creates this kind of mesh of internet measurements that lets us see what's going on along the paths between those anchors in terms of, say, latency changes or packet loss. Excuse me. So that's basically what we depended on for this analysis. So turning back to the events of November, Emil's first reaction when he heard about the outages was to go back and look at the RIPE Atlas anchor mesh. In particular, he looked at the countries that were supposed to be connected by these cables to see what kind of impact the events had on the internet around the region. We were quite lucky in this case because there's a pretty good distribution of anchors around in the countries around the Baltic Sea. As you see, we have loads in Germany. We also have enough in the other countries that we were looking at to work with. So that was very helpful. So this is what Emil went to look at, and this is what he saw. Right, okay, this takes a bit of explaining. Let me just quickly walk through what you're looking at here. And are the colours up there? Yeah, they're roughly the same, it's fine. So down the y-axis here, each tick along that axis is essentially a pair of anchors. So here we're looking at that first outage on the BCS cable. So each tick there is a pair with one anchor in Sweden and one anchor in Lithuania. And what we've got here is, over time, over those 4-minute intervals, as the anchors perform those measurements to each other, we get to see how latency changed over time along those intervals. The pale area in the middle of the heat map there is basically the baseline latency for all these paths. And then as you see more orange creeping in, that's an increase in latency along the path. So it's pretty clear there that around the time of the outage, it's approximately 8 o'clock in the morning on the 17th of November, a bunch of the paths that these anchors were using to ping each other started to see a big increase in latency. And this makes sense, you know, as the cable became unavailable, you know, the traffic was rerouting around that and taking longer paths. So yeah, just to be clear, the histogram at the top there, each bar of that is the kind of cumulative latency increase for across all those paths for that timestamp. And then the bars going over to the right, that histogram to the right, is the latency increase on each path. Okay. There's a visualization that we're still working on, but we're pretty happy with what it shows us so far. What's interesting here, though, and this is where you have to really, like, you know, pay attention to this whole story. Even though we see that increase in latency, we see that step increase in latency in the orange bars here. This black line going through that represents packet loss. So what you really see here is that even as that increase in latency occurred, we don't really see a concurrent increase in packet loss. Packet loss is always like kind of spiking. This data is messy. But even though the spike's there, they don't really change that much with that step in latency. So that's cool. That suggests that even though things were taking longer to get where they need to go, the packets were getting where they need to go. They were reaching their destination. And this is what we want to see for the internet. We see a similar picture when we look at the sea line 1 break. Here, the latency increase is around 5 milliseconds, which doesn't seem like a lot. It's a relatively minor increase in latency, but it all happens again for those same paths, for a fixed set, for a whole set of paths all at the same time, suggesting that that's when the break occurred. We also looked at the sea line 1 repair. Here, the repair occurred. I don't know if you can actually see me doing anything here, but the repair occurred about 5:30. That's when you see this little wobble in latency on the left, kind of in the middle. And then, ignoring that spike for the moment, you see things kind of settle down and everything goes back to normal as regular routing reestablishes itself. That spike, Emil's still scratching his head over there. We don't really know what happened there. We're still figuring this stuff out to a certain extent. But yeah, so this was basically the preliminary analysis that we performed. This is the content of the first article of the 2 that I mentioned before. And just summing up, there was definitely, as these cable breaks occurred, there was definitely a minor but visible shift in latency for around 20 to 30% of the paths between the observed anchors, but there wasn't a concurrent increase in packet loss from what we can see. And this is good. This is how it should be. The internet routed around the damage. And that's exactly what we want to see. It suggests that there was enough redundancy, there was enough alternative paths, and importantly, it shows that there was like enough capacity along those paths to actually carry the extra load. So this is great. This is a success story. We don't want to see cuts happening, but if this is how that looks, if this is how the internet reacted to them, then that's a really positive thing. Given that we'd been able to perform this analysis, we then started to look at what the anchor mesh could do, you know, with regards to other outages. And it's really nice now that we get these visualizations, we have these visualizations that we can just produce very quickly after an outage occurs. And it gives us a really good first view of what's going on there. So we've employed this for a couple of other cases already. This was a power outage in Chile in February. But Emil, you know, it's all very well doing that preliminary analysis. We all, you know, and it all completely makes sense. There's going to be a latency shift. There's, you know, it's cool that there's no packet loss. But Emil wanted to dive deeper into some questions here. In particular, you know, this is the internet being resilient. This is internet resilience. The internet has evolved to be resilient. But what does that resilience actually depend upon? You know, how is that achieved? Emil wanted to look closer at those questions. And while the initial analysis was just based on kind of end-to-end latencies that we saw in the ping measurements, the cool thing about the anchor mesh is that it also gives us traceroute data. So we could go and look more closely, in principle, at how the paths were actually changing and what was going on there to get a clear idea of how the rerouting was happening. Okay, so I'm not going to go into too much detail here, but what basically emerged as we started to look at this was that there are different levels of resilience when this kind of thing happens, that get revealed when this kind of thing happens. When we think of rerouting, we usually think in terms of, rerouting between networks and BGP and things like that. And we certainly saw a good deal of that taking place as the cable went down. But as Emil is looking at the trace routes, he's also seeing cases where there was actually no change in the AS paths for those paths where we saw those higher latencies. But rather, there were changes in the IP addresses. So this is when you get things like rerouting happening between the routers within the network. Emil refers to this as intra-domain rerouting. And this is where protocols like OSPF kick in. I'm no expert on this, but that's what Emil tells me. And that, that sort of takes care of rerouting at this level. But what was really interesting, and this sort of baffled me when Emil started talking about it, was that for some of the trace routes he's looking at, he didn't see any change in the AS path or the IP addresses along the path. So what's going on there? Well, it turns out that networks can actually, organizations that run the networks can actually invest in things like path protection. And this offers, redundant routes between routers on within a network. So there's essentially rerouting going on at what we're referring here to as the circuit level between the routers. So looking at those three levels of resilience, Emil started to break down how much of each different kind of rerouting was going on in the cases we were looking at. Here he focused on that Sea Lion 1 outage and the paths between Germany and Finland. And he sees that like each kind of rerouting, each level of resilience is evident here kind of in the wild, if you like. And that's cool. Like when we think about internet resilience, here we see that resilience isn't just happening between networks, there are actually different levels. And at each of those different levels, there are different protocols that are responsible for the rerouting that takes place, and different decisions have to be made to make sure that the proper redundancy is actually in place to handle these kinds of things. And that's kind of an important point to dwell on. We've been looking at success stories, and we tend to see quite a lot of success stories. The internet has evolved to be resilient for lots of reasons. But there are also other stories, and we also have to look at them. So one of the things that Emil started to look at was a few weeks ago, there was another outage for cables down the west coast of Africa, just off the Ivory Coast. And a whole bunch of cables were damaged by this submarine landslide all at the same time. So these were the ACE, the main one, SAT3, and the WACS cable going down the west African coast. Emil looked at these by looking at anchor pairs going between, it was the UK and South Africa. So they were the anchor pairs that he tapped into to see what was happening here. And this is the picture that he came up with. It's messy. This is a much rougher visualization than the other ones that I've shared with you today. But like, as a preliminary analysis of what was going on, this at least shows us that as that damage started to kick in, it's around 10 o'clock on the 14th of March, we do see these two kinds of rises in latency. But what's really sticking out here for us is that there was also a much greater concentration of packet loss around these events, which suggests that there wasn't the same redundancy that there was in those other cases, at least from what we can tell, looking at the data between the anchors. This either means that there weren't alternative paths, or there just wasn't enough capacity along those paths to handle the damage. So, what can we kind of conclude from all this? This is still very much ongoing research. we are still like looking at these events and trying to properly understand exactly what's going on there. But so far, this is kind of where we're at. In the Baltic Sea, the internet did route around damage. That's great. That's what we want the internet to do. And that rerouting depended on several different levels of resilience. It depends on redundancy between the networks, but it also depends on redundancy within the networks at the intra-domain level and the circuit level, as we were talking about before. But it's important to bear in mind that resilience isn't guaranteed. We can't take this for granted. The internet isn't always going to be able to bounce back. So we have to keep monitoring these kinds of events. We want to keep measuring them and seeing what kind of impact these events have on the internet. And we really want to keep trying to understand, what kind of impact the events have, how we can, where the vulnerabilities are really, and how we can better protect against those vulnerabilities. And that's something that we hope RIPE Atlas can keep helping us to do. And so that's kind of the conclusion of all of the above. But before I stop, I just want to emphasize that, the RIPE NCC does act as a neutral source of internet measurement data. And all of the data that I presented to you today is available to any internet researcher to go and dig into that and start doing their own analyses. But in order for that to be really useful to people, we need those vantage points. We need those probes and those anchors out there. We have to do a lot of work to make sure that deployment, that we get enough coverage, that we get the coverage we need so that we have those, that view on these events. I just did a little look before I came down at like the distribution of anchors across the sea region. We could maybe be doing a bit better in some countries in the sea region. But all in all, we have quite a few anchors dotted about the region, enough to probably give us something to work with should similar events happen around here. Me and Mila were also speculating how much we would see, for example, if this cable in the Black Sea was actually damaged, how good a view of that would we have. Something Emil's kind of toying around with at the moment. And one other important thing here is to keep in mind that we're trying to be more strategic. We're working on different methods for looking at where we actually need anchors, so that we, instead of like potential hosts approaching us, we can go and talk to people in the networks where we need anchors, and approach them and ask for their participation in RIPE Atlas. And we also do this with the RIPE Atlas anchors, RIPE Atlas probes, and when we look at the distribution of probes across the sea region, I'm really happy to see that we have pretty good coverage. This is really promising to see all this green here. So yeah, I'd just like to end by really thanking the internet community in the sea region for participating in RIPE Atlas and helping us to make sure that we have useful internet measurement data for the region through RIPE Atlas. And yeah, as I say, if you have any very technical questions, I would save them for Emil, please. But if you have any other questions, I'm here to take them. Thank you.
Yeah, feel free. And also, if anybody else has questions, please step in the queue. And
Yuval from Tel Aviv University. So yeah, first of all, it's really impressive to see how good the internet is really managed to bypass those things. But I think that we should expand our view from the engineering point of view. We know from the Snowden report that when the US was trying to spy on Yemen, they were trying to divert traffic to networks where they actually have a tap to be able to grab traffic. And we don't know I mean, we know these things was probably done by the Russians, and maybe the traffic going around with not such great additional delay was actually going now through networks or through locations where the Russians could actually pick up the traffic and do something with it. So if we limit ourselves only to the engineering point of view, we might be missing the point of this entire event.
Yeah, I mean, our role, like I say, is really to make this data available so that people can go and perform their own analyses of this. There's a couple of episodes of the Ripe Labs podcast, actually, where we talk to people like Bert Hubert, talks at length quite a lot about like how we need to look closer at like where the traffic's actually going. So I'd encourage you to go take a look at them. But like I say, for us, we just want to make the data available, and then people can go and perform their own analyses.
Do we have any more questions? No.
Okay.
Thank you.
Thank you very much.
I would now like to ask Mirjam Kühne, the RIPE chair, to give us an update about the RIPE community. Mirjam, so since you're the chair, you have a 1 hour slot. So we're a bit of
Thank you. Yeah, I'm not going to fill an hour. You might already think of how to, spend the rest half hour of the session because you're probably not going to have that much. But yeah, thanks, Alun, for this presentation, and this was really insightful. And this also shows a really nice, collaboration between the RIPE NCC and the community, because what you said at the end, without the community and the volunteers to host those probes, without the operators to actually look at how they route traffic, and then also, and on the other hand, without the RIPE NCC, to look at the data and make it available, we would not have this kind of insight. So that was really very interesting. Now, something completely different, a lot more high level, not so technical. Thanks for the invitation. I'm Mirjam Kühne. I'm the chair of the RIPE community, where the SEE community is part of course. And so I would like to give you a bit of an update of what's currently happening in the RIPE community on various levels. So it's a bit of a mixed bag of some highlights. First of all, welcome to this event again, also from me, and a special welcome also to the newcomers. I'm always impressed how many newcomers we have at these SEE events. We had for the first time at this meeting kind of a bit of a short last-minute edition. We had a newcomers session earlier today, which I really enjoyed because there were already some questions and interactions, and I hope some of the newcomers will come back to the next SEE meeting and maybe also to other events like the RIPE meetings, for instance. As you might know, the RIPE meeting is a bit more, or the RIPE community, has also working groups, so it's not only plenary sessions and workshops as here in the SEE region, but also it has a number of working groups, I think 12 or 13 at the moment, depending on how you count. I'm not going to go through all of them, but I just want to give you a few highlights of the discussions that are currently happening there. And the address policy working group is a place where policies for address distribution are being discussed and debated and decided. There's currently a proposal, they're numbered. This one is 2024-02. So therefore, it's already from last year. It's a proposal to increase the initial IPv6 allocation to /28. That's currently being discussed, and there will be a decision at some point made by the working group, by the RIPE working group chairs. There's another discussion about revisiting the criteria for AS number assignments at the moment. So there's a proposal that's been, or it's not quite a proposal yet, it's an idea that's been shared with the working group on the working group mailing list, looking at the current criteria for AS number assignments and possibly amending them. And then also, maybe a bit in the background, but we've been talking about this for a while, is we're actually reviewing together with the RIPE NCC the whole policy portfolio, if you will. So they've been added. We added policies throughout the years, and it's become maybe a bit more complex than we wish. And we're looking at, can we maybe merge some of them? Could we make them a bit more, simplify them, make them more accessible for members of the RIPE NCC? And so that's we have a long-term project that we started. RIPE Database Working Group is mainly working on additional functionality, cleaning up data in the RIPE database. It's kind of a long ongoing working group, and they have a list of, they call them numbered work items, they're kind of action points, and they're going through them together with the RIPE NCC, and that's also an ongoing work. In the routing working group, there was an idea shared to possibly automatically revoke persistently non-functional delegated certificate authority. So that's related to RPKI and how it's registered in the RIPE database. So there was some interest in this. This might become a policy proposal. We'll see what's happening with this maybe at the next RIPE meeting. And then there's it's not a new working group, it has a new name. It used to be the Anti-Abuse Working Group, has changed its name and also has a new charter since the last RIPE meeting. And there's also an interesting discussion recently about transparency reports the RIPE NCC frequently publishes from requests they receive from law enforcement agencies, and what the community can do about those. So there will also be presentations at the RIPE meeting. Actually, most of the working groups have issued their calls for agenda items, and there will be some really interesting presentations also. For instance, in the cooperation working group, we talked about it this morning, also in the government roundtable meeting. Big topics there, of course, will be the upcoming Internet Governance Forum, the WSIS and +20 review, what the community can do, what kind of input the community can give for these topics. Some other initiatives that are going on kind of outside the working groups. There's one, Best Current Operational Practices Task Force that Jan is actually heavily involved with. He's one of the co-chairs. And they've been proposing last time to possibly document how we make consensus decisions in RIPE. I mean, we heavily base the process on the IETF consensus building RFC. But there might be some differences, and maybe we're doing things differently in RIPE than, for instance, in other regions. And so we've been looking into this and make it easier, understandable for participants, also for working group chairs who then have to deal with consensus building decisions in their working groups. And so that's an ongoing activity. We might have a draft before the next RIPE meeting. We'll see, we're working on the text right now. Another initiative that's kind of going on a little bit in the background, and I think it actually might have started here recently, also looking at sustainability and networking. There were some presentations at earlier RIPE meetings on the topic. It's kind of, on and off, topics that are on the agenda, but there's no, working group or no task force or activity on this. But it might be interesting, to look into this also. What does this mean for small and medium enterprises? What are the resources out there? What are the requirements and regulations that operators might have to fulfill soon or already now? If there's any interest in this, come talk to me or possibly also to Jan. This could be an activity in the Best Current Practices Task Force. There are some articles already on RIPE Labs that Alun has mentioned earlier, the blog that Alun is maintaining on that topic. So if you're interested in that, there are some really helpful resources in that on RIPE Labs as well. Then some other kind of RIPE governance topics, how I want to call them, that are ongoing right now. And we've been working a lot on documenting how we do things in RIPE. What's the task force? How do we make decisions? What's the role of the RIPE NCC staff in the RIPE community? And the most recent document on this was the relationship between RIPE and the RIPE NCC. And there's often kind of a bit confusion about this. Also, how does this all started? Why are there these two organizations? What are our roles? And so we've documented this. It's really documenting the status quo, how RIPE NCC and RIPE work together, how do we mutually support each other, as for instance the RIPE NCC provides secretariat services to the RIPE community. On the other hand, the RIPE community provides guidance on their services to the RIPE NCC, including also the policies that the RIPE NCC implements. And so we documented this there, and shared it with the RIPE community, and the RIPE community has reviewed it, and we made some small changes, and there's now consensus, and we'll be publishing it as a RIPE document soon. And I think this will be helpful also for stakeholders maybe that aren't so familiar with our community to read how this works together and who does what and why it's been so successful, if I may say so. Then also a few words on RIPE leadership. There's always, the terms of working group chairs are ending, and so usually pretty much at every RIPE meeting, some of the working groups are looking for new co-chairs, and so in this case, it's the address policy working group and the IoT working group who are looking at new co-chairs, and so we might see some selection going on there at the next RIPE meeting. And I just want to point this out here. There's a really good training module that the RIPE NCC has put together for current and also future working group chairs. So if you're interested in one of those leadership roles, I would recommend you to look at that. The RIPE NCC can share the link with you if you're interested in that. It's really modular, so you can pick out, for instance, there's one really good one also on consensus building if you're interested in that. And then there's also an activity going on. There's a RIPE nominating committee, again, that Jan is involved with. He's one of the chairs, and I think some other NOMCOM members are also here at the SEE meeting. And what the NOMCOM is currently doing is looking at the next RIPE chair team. So I'm the RIPE chair. There's a vice chair, Neil O'Reilly. He's not here yet. Our terms end in October, and the NOMCOM is currently looking at the next chair team. So they're looking for feedback from you also. So I'm sure they'll be happy to also get feedback from you here during the meeting. And yeah, I'm not going to say more time frame. It's going on over the next few months. So the next RIPE meeting will also be a good opportunity to provide feedback. And a few words about a lot of acronyms on the title there. The Address Supporting Organizations Address Council has been reviewing a document that's called ICP2. I don't even know what that stands for, Internet something policy. It's a document series that ICANN maintains, but I think there are only 3 documents in that series. And the second one dealt with, or still deals with, I mean, it's still valid, deals with the criteria how to set up new regional internet registries. And it's been set up, this document dates back to 2001 and was mostly written at the time by the then existing RIRs when LACNIC and AFRINIC were about to be established. But it actually is based on older criteria even that the IETF published back in the 90s on how would they see a distribution of IP addresses through a regional system. And so there is an RFC already 1466, I think, that has already some really interesting criteria. And one that I always find very good and to read back and to see that it's such an old criteria is the community involvement. Even early on, it was understood that without community support and without this community engagement that we're also doing here, it would be really difficult for an organization to play this role of an RIR and as a community a registry, IP registry. So anyway, there are some reasons why the ASO/ASC has been reviewing this document, and so they realized there are some gaps and there might be some additions, and so they started to look at the document. And it's been a whole long process to gather feedback also from all the communities. And RIPE NCC is organizing, and I think all the other regions also are organizing these open houses online over the next few months and weeks. And there's a link at the bottom where you can really find a lot of the whole background and the current status of this. But I'm going to try to walk you through an interesting graph that I was provided with here, just to show you how intricate this is and also how how much influence and input the community has in this process. So it started really last year with a review of this document, this ICP2 document. Then the ASO/SE decided, rather than just opening the document and trying to rewrite it, they took a step back and wrote down some principles. So what are the principles? What should the principles be for an RIR, to run on successful operations? And so they published these principles. They asked the communities worldwide for input. They got feedback and summarized the input. Actually, the RIPE-NCC staff, together with staff from the other RIRs, were very helpful in this process. They summarized the process, the feedback that was received on the principles. It's all public. You can read all the comments. And now the ASO/SE is starting to actually draft the new document based on the feedback received, based on the principles that they've written down. And so currently is time for, it's just starting, like public comments on the draft. The first draft will be published soon. At the next RIPE meeting, we'll actually have a real and thorough discussion, I think, on this draft. And then throughout the year, there will be discussions in all the other regions as well. And also in the ICANN community, of course, because ICANN will have the final review and the final approval of this document, hopefully sometime later this year. So that's the whole process. Why is this relevant to us as a community? Obviously, because we need a stable RIR, like IP registry system. And we as a community here and also globally, we need to support our RIRs wherever we are to make sure we have a stable system in place there. That's last but not least, some words about what we do in terms of outreach. I already mentioned the newcomer session here, and we're doing this also in front of RIPE meetings. We used to have, we have online events like open houses and online events for newcomers and for students. And now for the first time, I think, or at least for a while already, there will also be some physical, trainings and outreach that RIPE-NCC, is Jelena here? I don't see her, but I think Jelena and some other staff will be going to universities in Lisbon in front of the RIPE meetings to make sure, to reach out to students and attract them to come to the RIPE meeting, which will happen in Lisbon. I'll get to that. And of course, we also have fellowship programs in place for people both from the academic world and also just diversity fellowships to ensure we have a good attendance at these meetings. Just like we have that here also for the SEE meeting. And then lastly, the RIPE chair team, so Neil and myself, we're also on the road sometimes, so we're following a lot of the discussions and the developments going on in the internet governance world, and also in the industry in general. So as I said earlier, I'll be participating in the government roundtable meeting. I'll be at the Internet Governance Forum. We're also attending a lot of the technical industry events, the academic, like GÉANT events, the NOG exchange point meetings, IETF meetings, ICANN meetings, just to stay up to date and to make sure we can report back to the community. We're always publishing a monthly update on the RIPE Labs blog that was mentioned earlier, where we kind of keep the community up to date of what's going on and where we've been and what we've learned and what's relevant to the community. And then, lastly, the RIPE 90 meeting taking place in Lisbon in May. You see here, this is an overview of the weekly schedule. Is a bit more complex than we have here in the SEE meeting at the moment. So we also have all these working groups meeting there, plenary sessions. There's a diversity and inclusion session that we are still finalizing the topics for. There's a general meeting from RIPE-NCC for RIPE-NCC members on Wednesdays, and a lot of free space and free time to network and to talk to each other and to get to know each other and to talk about these fascinating topics like the one Alun has just presented. And of course, more networking opportunities with social events, and you can find a lot of more information on the RIPE 90 website about the sponsors and the socials and the whole program as it is right now. So the agenda is not finalized yet. So every working group is working on the agenda right now, and it will be published soon. So I hope some of you will join us there. And yeah, are there any questions? I think this is all, yes.
Thank you, Mirjam. Now we have half an hour for questions.
Yes.
Otherwise, we will all
Bring
sit
it on.
here for half an hour and not go anywhere.
Okay.
Are there any questions? No? The questions outside. Well,
I'm sorry.
we paid for snow. Okay, so if there are no questions, well, we will have an hour of a coffee break, apparently.
Okay. Well, it's up to you. You're the
Thank
session
you
chair.
very much.
Thank you. You're welcome.
So be back at 4. We will have an interesting presentation session with the panel and the lightning talks. Thank you very much.
The next session. So introducing Tomaz Zaman, who will talk about a bit about building a home router. Tomaz, please.
Thank you. So, hi, my name is Tomaz Zaman, and this is my first time at a RIPE conference. I hope that at the end of this talk it won't also be my last. Jan is already sweating a bit. Don't worry, Jan, I got it. And yeah, in this talk I'd like to talk about the challenges we are facing when building our own home router. I'm also a YouTuber, which means for the most part I have no idea what I'm doing. But for some reason, people seem to enjoy at least talking about having no idea what I'm doing. So once I expressed my willingness or desire to build my own router to sell at the end of the day, I garnered quite a lot of people following the whole story with enthusiasm. And more so, or even more importantly, a couple of investors sent me an email saying like, hey Tomaz, I'm following your story on YouTube and I'd really like to financially support this whole endeavor. So I can proudly say we're also a venture-funded startup. We raised 300K last year. The two biggest investors are one British ISP and one Silicon Valley fund. And they all found me on internet, which I think is pretty great. And you know, internet is the reason we're here today, so even better, right? So this is the device that we're building, and this is why there's 936 grams to it, right? It's milled out of a solid block of aluminum. And before you ask why, let me ask you back, why not, right? So we decided that all the routers that we've been dealing with, not just routers, not just networking gear, but gear in general, they cut a lot of, or they save a lot of money, but the manufacturers, by going with some cheap stuff that breaks easily, gets turned into e-waste far earlier than it's supposed to, I guess. So we said, okay, let's make something that is environmentally more friendly, more durable, and dare I say, also looks prettier. But before we get into the actual challenges, let me go to the beginning of this story. And it was January of 2020. And luckily for me, it was just 2 months before our favorite global pandemic struck. So I got my gigabit fiber just 2 months before, which was perfect, right? However, this is what I've been giving as my ISP's router of choice. Now, is there somebody who works for AVM here? Okay, good. And I'm not throwing shade at them. Actually, this device is pretty good for its price, right? But my network rack at home looks good, let's say, right? So let's say just aesthetically, this didn't fit. So I immediately called support and said, listen, can I have something better? And they say, well, you're a business customer, so this is something better, which, you know, makes me think what non-business customers are getting, right? But apart from, you know, vanity side of things, there was also one bigger issue, at least in my opinion, and that's the fact I didn't get root access to the device. Like, how can I get how can I not get root access to the most important networking device in my home? That didn't sit well with me, right? So what I did is, well, the Fritzbox that I'm talking about had one redeeming quality to it, and that's the fact that it comes with a separate SFP transceiver, right? So I called support again, they love me, I guess, by now, and said, listen, can I take this transceiver and put it in my own gear? And they said, no, you cannot do that. So I tried it anyway, right? But it didn't work. And the reason it didn't work is because the SFP transceiver, you probably know that, needs some kind of way, at least in GPON, needs a way to authenticate with the switch, with the ISP side of things, right? And this is not the picture of that transceiver, but it looks the same. Anyway, it did not want to authenticate when it was in my own switch, right? However, there was pandemic going on, so I had plenty of time. So I discovered, long story short, that when this transceiver is plugged into the Fritzbox, through some non-standard, non-documented, nothing hidden protocol, pushes the serial number onto the SFP module for it then to authenticate with the switch on the other hand, right? So what I did is I turned off, or I unplugged all the devices on the network except my PC, and then I turned off, because luckily their OS has a packet capture utility, so I just ran packet capture on WAN port, plugged in the SFP module, and I saw the data going through, right? Through two internal ports that weren't visible otherwise. So I was like, you know what? I'm just gonna grab this data, write my own script, put it on my own gear, and just run what is called a replay attack. And that worked for like 2 years probably on my network, so I successfully moved the SFP module into my router, or into my switch that was controlled by my router, and it all worked beautifully. Except when it didn't, and my wife called me when I was giving a talk on a conference or something. I said, just plug it out and plug it back in, and it will start to work again, right? The normal customer support response, I guess, right? And I even called the telecom. I was like, listen guys, this is what I've done. And my wife was like, before I made the call, my wife was like panicking, like, they'll arrest you or something. I'm like, chill, let me talk to their cybersecurity guy. You know what his response was after hearing this story? He said, do you need a job? And I was like, yes, I guess I did something right. Anyway, later on I discovered that fs.com sells configurable modules, SFP modules, that are one-on-one compatible with what I was given. So now I'm doing things the right way, meaning that I don't need a replay attack anymore, and I just configured like an empty SFP module with the correct serial, and everybody's happy. However, at the time I was using one of the Ubiquiti switches, and their support also pissed me off. I guess I'm easily pissed off, sorry. So I was like, okay, what they didn't do is they didn't provide a feature called IGMP snooping, which I also needed for my network. So I was like, okay, all these things don't work the way I wanted them to work, so I'll make my own router and it'll solve all these issues, right? So the first choice, once I started to look into what kind of technology we were going with, the first choice I had to make, and I keep getting asked on through my YouTube comments and the community we're building, is why didn't we go with x86? x86, when you approached Intel or AMD and say you want to buy 1,000 CPUs from them, they're going to laugh you out of the door. That's the sad reality, right? You either buy 1 or 2 in a general store with electronics, or you buy 100,000. There's no in between, right? However, vendors for ARM CPUs are more than happy to sell you any quantity, really. Plus, there's an additional reason. ARM CPUs, for the most part, have some kind of networking hardware built in, whereas x86 are, for the most part, just generic, general-purpose CPUs. So x86 was out. Once we decided we're going to go with an ARM architecture, the next choice we had to make was whether we're going to go with NXP or Marvell, the two, I would say, world-leading manufacturers of CPUs for networking purposes. And unfortunately, it is what it is. Marvell's chips are pretty much 2 times to 3 times more expensive for exactly the same amount of functionality that they offer. So simply for monetary reasons, we said, okay, let's go with NXP, right? The next requirement we had was that we wanted at least 2 10 gigabit ports. As I said, I'm a big opponent of e-waste. So we want our device to also be forward-looking, and we want it to work, happily for 10, 15 years. So we said, okay, it needs to have, and the 2 ports that router needs are WAN and LAN. So we said at least 2 gigabit ports that it needs to have, right? So what we settled on is a CPU called NXP Layerscape LS1046A, which is for $70. Supports everything that we needed to. So you can have either 2 or 4 general purpose ARM cores. It supports up to 16 gigabytes of RAM with it. ECC support has plenty of gigabit interfaces, the 2 10 gigs. It has 1 PCIe 3 lane, which we'll get to why is it important shortly. But more importantly, it has something called hardware offloading. Unlike your general purpose, Intel or AMD CPUs that you're used to from your PCs, networking CPUs usually have 2 parts to them. One part being the general purpose ARM cores that are just, running Linux or whatever. And then the second part, the ASIC part, is where the magic happens. So it's these ASIC parts that are handling the traffic, even 10 gigabit, even 20 at least. So our CPU has up to 26 gigabits per second of hardware offloading, meaning it can handle that much almost without interfering or having to use the general purpose cores, right? So I can push 26 gigabits per second, and the general cores will be at 0 utilization this whole time, right? And that's the magic part of it. What can it hardware offload? I didn't list all of it, but pretty much all of it. Like whatever you can imagine, like at least, unless you're talking some kind of exotic protocols, it can do hardware offloading. So we've tried, regular traffic, so routing, PPPoE, VLANs, network address translations. It even supports, though we haven't gotten there yet, so intrusion prevention system up to 36,000 rules on a 10 gig connection in real time, which is pretty amazing. However, NXP is a little bit shy when it comes to documentation, as in it's really hard to get by. So yeah, that's, I guess, the downside. The next decision we made was the form factor. We wanted to go with something small, non-bulky, so if people or potential customers decided they want to put it, somewhere on a shelf and not be too unobtrusive, yeah, I guess. Anyway, so we wanted to go with nano ITX. The thing is, ITX is a standard. Micro ITX is also a standard, but when you get into nano ITX, it is not a standard, despite the fact that if you Google it, you'll find a lot of documentation saying, yeah, this is how it's, but official standard does not exist at all. We even wrote to VIA, the company that used to make motherboards, like, I mean, you're as old as me, so you know VIA, right? We didn't get any response, so we said, okay, we're gonna go with a nano ITX-ish form factor. But with small real estate also comes a lot of limitations, right? And what we wanted to put was almost, on the PCB itself, was almost too much for the board to handle. We managed, but if we wanted to add like one more thing, we would fail, basically. So the parts or the features that we wanted to put in was, as I said, so 2 SFP cages for 10 gig, 3 RJ45s for gigabit. Then people on the internets were very vocal that we shouldn't put a 12-volt barrel plug because that's outdated. Now all the cool kids use USB-C power delivery, right? So we said, okay, if the community wants USB-C power delivery, we're gonna give it to them. Apart from that, we also needed a port for a console for debugging purposes. We planned 8 gigabytes of RAM, plus additional chips for NAND, which is for bootloader and OS, and also at the same time have 2 mechanical, like physical M.2 ports to support wireless, and also have a battery socket on the board. And this is how the final product looks like. This is almost fresh out of the oven. Literally the first prototypes were manufactured this January, and this is one of the 6 prototypes. I have one with me, so if you want to gently hold it after the talk, approach me, and yeah, you'll be able to gently hold it. The good part is we succeeded with what's called a board bring-up. The board bring-up is a process in which you turn a board that comes out of the oven, literally like the manufacturing, that you turn it into a fully functional device, right? When you have a bare, naked board that doesn't know anything, well, it doesn't know anything. You have to program it to do something, right? And this is what the bring-up process is for. So you search for bugs. We did have plenty of them, actually, but we worked around them. So we ended up, basically this board, and I have it with me, now boots into Linux, and all interfaces work. So for like 2 people to work on it for like a month and a half, I'd say is a pretty good outcome or result, really. Now let's talk about some of the real estate on the PCB and how it was used, I guess. So the 2 most important, I would say, parts are, of course, the 10 gigabit ports, because this is the whole shtick, right? We want to support 10 gigabit from the get-go, and are by far the most intense, complicated, complex parts, right? Apart from the boards themselves, here, okay, yeah. So in order for the boards to work, you need 3 components, or 4. So you need a CPU, which is like a Mac controller, right? Then you need what is called a retimer chip. A retimer it has 2 purposes, a retimer chip. First, it fixes the eye diagram. You know what who knows what a eye diagram is? Okay, so an eye diagram is when you receive over the wire, you receive 1 bit, right? It goes from 0 to 1, right? And then when your signal is 0, it doesn't just magically turn into 1, right? It needs some time if you zoom in enough. So between 0 volts and whatever voltage the data transmission is in, it needs some time if you zoom, right? And the flatter it is, the bigger the possibility for errors in transmission of the data, right? So, and this gets compounded or even enhanced in, when you have your wires all over and there's interference from your phones and whatnot. So you need something to make sure that the eye diagram, so that the slope is nice when it leaves the CPU and when it goes into the CPU. And this is the purpose of the retimer chip. It is a signal enhancer / polisher. But it also has a secondary, for us, I'd argue even more important function. It acts as a translator. Most CPUs today have the protocol that they use in order to talk 10 gig. 10 minutes left. Oh shit. Okay. Yeah. So I need to speed up. So yeah, anyway. So the retimer basically. Now I lost my train of thought. You owe me a drink, sir. Okay, yes. So the CPU talks in a protocol called XFI, the interface, whereas SFP modules talk through an interface called SFI, and they're not electronically the same, so you need to basically have a translator. And this is the chip. But in order for it to work at 10 gigahertz, it also needs a reference clock, which is this chip. You know how much this chip costs, retimer? $15. You know what also costs $15? A Fritzbox. Again, no shade. It needs to be cheap, right, for the telecoms to give them out so freely. So the next challenge were the RJ45s. Who knows what a PHY chip is? Okay, so in OSI networking model, you folks mostly talk about layer 3 and 4, right? TCP, IP, UDP, whatever. This is layer 1 device. So on the CPU, you have a MAC controller that is a layer 2 device. Then you need someone or some chip to translate between layer 2, which is in bits, to layer 1, which is analog signal that comes over the wire. And between them, you put what are called magnetics. Magnetics are basically just two transformers that are one-to-one wired and basically prevent the bad power that can come through the wires to get into the CPU, right? So they're a safety mechanism. But you've mostly seen RJ45s that are shielded, right, and have magnetics built in. That's the regular practice. However, we wanted our device to also look good. So we wanted plastic ports, so that's why we chose a separate route, right? So the solution, because we were out of standoffs or out of real estate for corner holes, we used standoffs, right, to be able to mount it into the chassis. We also designed our own, as I said earlier, USB-C power delivery. This is the power delivery, and this is, you get 20 volts in, and you got push 20 volts into 5 volts, and this is 3.3 volts, right? You need all these voltages, and of course, every converter takes its own real estate, and quite a lot of it actually, right? We have 8 power supplies. So 5 volt, 3.3, then we have 2.2, 1.2 for, 2.5 and 1.2 for memories, 1 volt for core, and 1.3 for networking, right? So this is the final development kit version of the device, which we already sold 700 of them. So we have 700 people that already paid for this device, though it's not manufactured yet. We're debugging, but YouTube works, I guess you could say. So that's pretty great. And before we close this down, let's also talk about the memories, because these are the most and the least fun at the same time. So we have 2 main storage. This is the NOR flash. NOR flash are really small but very resilient devices, right? This NOR only takes 64 megabytes of data, but it's enough for a bootloader like U-boot or UFI. And eMMC is pretty much the same chip that you find in SD cards, right? In our case, it's 32 gigabytes of general purpose storage, right? And then we have 5 memory chips, which are making me really old really fast, because memories run at 800 megahertz. That's 800 million clock cycles every second, right? And just to have an idea, all these memories take around 200 traces that need to be routed from the CPU into the chips, right? And if traces are off by a millimeter even, it can, okay, that's not me yet. If they're off by a millimeter, it can corrupt the signal and not work. And we haven't gotten to this part. But we didn't solve it yet. So you have about 1,000 options that you need to set in the CPU, how to talk to the memory, and every one of them can screw you up, basically, right? So we're not done with this part. It's basically going on right now. And the other part I also need to mention is the user experience, I would say. So we put 2 ports. You can see 2 M.2 ports for Wi-Fi and the battery holder there. Because for us, user experience matters, and we want to make sure that it's easy for the end users to take it apart. So we made the bottom magnetic and replaced the M.2 cards and the battery, right? I'm rushing it so I don't run out of time. Yes, sir. We spoke about this. I spoke about, I'm faster than I thought. We spoke about memories. Yeah, but what about networking? Open source, I love it. I made my career in open source, but I believe it needs a lot more work. Our router is focused on Linux, but the primary purpose is that we want to give people a choice. So if you want to run FreeBSD, you can. If you want to run Linux, you can. Windows, I don't know, no. But we want to. The point of this device is a choice. Nothing is locked. Not only do we not prevent anybody to do anything, we encourage as long as they report back their successes or their failures, so we might help out, right? I won't go through each of these, but the one I will mention is VPP. So we managed to hardware overload VPP, which is vector packet processing. It's a great technology, but not very user-friendly. And what we want to focus on in the next year or so is build an interface on top of VPP. I don't know whether we'll succeed. Cross your fingers, or how do you call it? Like, wish us luck that we'll succeed. I come from a WordPress background, so open source is very dear to me. And WordPress I've been in that community for 10 years until I sold my company in 2022. And WordPress has one mantra to it, and that is democratizing publishing, right? What we want to do is we want to democratize home networks with our device, right? So what are the plans for the next half a year? So we need to finish the bring up. We need to finish the enclosure. What you've seen are prototypes for the most part. Make an MVP, which will be sold with OpenWRT, because that's also already supported. We tested it. We know it works. We're confident selling that kind of device. But most importantly, we want to build a community. And I think we're succeeding in that. Because as I showed you earlier, my YouTube channel already has 50,000 subscribers. And I don't mean this as a bragging point, but as a leverage or a starting point in which I can invite people over and participate in our journey, right? Like a famous YouTuber once said, like, share, and subscribe. Thank you.
Do we have any questions?
Oh, Jan will be mad at me now, no?
Hello, Tomaz.
Hi, Jan.
I'm Jan.
I'm Tomaz.
Okay, can you go back and put up the picture of the beautiful fronts with the ports? And you know what I'm going to ask you, right? Yes, no.
Oh, this one. Go.
We had this discussion before about the LED lights. Now you have a full room of network engineers.
Yes.
Ask them, if you don't believe me,
okay,
would it be helpful to have the LED lights at the UTP ports or not?
There are no LED lights? So, there are. The one thing this is a personal pet peeve. I like lights as the next guy, don't get me wrong. But those lights constantly blinking, like because we have a switch under the television, and my wife is going nuts always because, you know, has a lot of lights. She liked them at first, but grew bored of them really fast. So we were like, okay, let's put the lights on as debugging, and you can see them here. They're in pairs, right? So each of them corresponds to pairs, right? Because we want to. When you don't want to look at them, we give you Jan. We give people choice. So there are no lights for people that don't want them. If you want to look at them, just turn the device around, take the lid off, and it's magnetic. You don't even need a screwdriver. Just pop it off. You see the lights. Problem solved. Everybody's happy.
Hello, Andrei Zoetka, Raipen CC. I have actually two questions. One is, I wonder if this is the place where you put the Wi-Fi, where are supposed the antennas to be? Because probably not in the box.
Yeah, so the primary, initially we didn't even want to put Wi-Fi on the board, but due to popular demand, we explored some options. We're not quite finishing exploring those options. However, we have two solutions possible. One, you can already see there's a little hole here. So we're working with a design studio on the enclosure itself. So one of the options was that that hole over there would be used as a cable for an antenna, right? That you would route outside, because obviously this is aluminum. The second choice that we'll go with probably soon is that this is also very expensive to make, CNCing aluminum, but I still want an aluminum enclosure. So the compromise we decided we'll go with is that the bottom two parts will be plastic, right? So, then if you put plastic and it's lifted a little, it's hard to see here, but it is lifted off the ground. Should be just enough that if you put antennas, like, you know, imagine a hole, not a hole, but an indentation here with a Wi-Fi antenna, it'll be good enough for a small apartment, for example, right?
Okay, thank you. And the second question is, this looks very similar to me to the project Tourist that is done by CZNIC for like 13 years already.
Yeah.
They are trying to build such routers. So I wonder what made you start it and what did you find not nice about them?
I mean, you know, building your own stuff is more interesting than just buying someone else's, right?
Of course.
But the underlying, like, when I show and when I talk about our project, the one thing I have to emphasize is this is not the end. This is the beginning. So what I'm passionate about, very passionate in fact, is user experience. You know, because I watched the OpenWRT, you know, earlier, and I thought to myself, like, what of these words would my mom understand, right? Probably a thank you at the end, and that's it. So how can we bring networking, especially home networking, to be more interesting, easier to understand for, you know, my mom? She's very not technical, obviously. So hi, mom. Anyway, what we want to get to is have an open-sourced operating system that is user-friendly. I'll give you an example. I am a fan of, hardware-wise, I'm a fan of MikroTiks. It's very cheap, it's very capable, reliable, works, right? Their operating system is not according to what I would see an ideal system be, right? And so I asked myself, can we make it better? Obviously, we're nowhere near where we want to be, but I dare say that throughout my career, I built a big enough network, and I'm doing this now as well, to gather people that are much better in this than me, that we can build something together, right? That's the dream. If it will pan out, we'll see.
Okay, thank you very much.
Thank you.
Hi, I'm short. I'm Laura Lorenta, speaking for myself as a startup hardware-based founder as well. And I'm actually curious about something that has been touched but not covered as much as I would love to. Mm-hmm. Well, I understood that this is something that was growing and growing, and then you build the YouTube channel and stuff. Many hardware-based startups consider Kickstarter as a platform to get and raise money for their projects. I wonder to what extent did you consider that or not, as you have built this community yourself with Europe. And the other question relates to the BC funding. BC funding it has its own rules and ways, and you need to learn that very well so you don't get, you know, when you close a deal, you make sure that you give away so many shares. So I wonder, when they approached it, how did you handle that? How was it? Mm-hmm. Very curious about that. Thank you.
Thank you for the questions. So the first one, what was the first question?
Kickstarter.
Oh yeah, so Kickstarter, we decided we're gonna just build our own page with prepayments, which we put out, and people did wire their hard-earned money through. I'm not a fan of Kickstarter because I would hate to be the founder that has to apologize months on end why things go wrong, which is why we also for the pre-orders, we're only taking, let's call it $100 reservation fee, right? You don't have to pay for the whole device. And that's because I am fairly okay with VCs. I know my way around them. Even the company I did sell a couple of years ago, we did raise a good $500,000 and had a successful exit. So now I would argue that it's kind of easier for me to raise money because I have a proven track record, despite the fact that for the most part I don't know what I'm doing. But somehow it just worked out, and we had a successful exit. So yeah, in this round, so these $300K that we got was quite easier to raise, right? And if it fails, I'd still be embarrassed in front of one VC or 5 of them, rather than 2,000 folks that paid for the device, right? I would rather play with the money that is there to be played with, quote unquote, rather than play with people's money, if you know what I mean, right? Did it answer both of your questions in a way?
Yes, it did.
Perfect, thank you.
Thank you to Tomaz.
Thank you.
And now we're off to NOG panel on NOGs. Okay. So Alastair on the panel on the future of NOGs.
I'd like to just thank Thomas for such the low energy that I now have to follow. You really set me up here. Good afternoon, everyone. My name's Alastair Strachan. I work at the RIPE NCC as one of the community development officers. I have a long history with the RIPE community. I've been at the NCC for a number of years. I don't want to age myself, but it's definitely above 10. I started off in customer service and I've moved through a few different areas, but now I'm one of the community development officers. And within that, I have a few different hats, and one of them being my favorite or the most passionate one I have is as the coordinator for all the NOGs within our service region. Now, I'm just going to do a quick cover of what we as the NCC do, the NOGs we have, and then I'm going to invite the panel up to have a discussion on where NOGs are, where they're going, and why they're so important. So within our service region, so we cover 76 countries. I've put there's 36 NOGs. There's a very loose description as to what a NOG is, and we'll touch on this on the panel. Some are simply Telegram groups. Some are full-on commercial entities whose events are solely purposed on commercial activities. So it really varies, but as a whole, the NOGs that we interact with regularly it's 36. The oldest being SWENOG, so that's Switzerland, and that started in 2000. The newest, my comms department actually came up to me just before and was like, do you need to add something on this? I was like, no, it's intentional, TBD. We see NOGs and groups appearing, disappearing, starting all the time. I would say at this point, the newest is Baltic NOG, which was launched, I think, a month ago. They have their meeting later in the year, but we always see people trying to form NOGs, or as I say, we have these informal groups or just a meet-up once a month, things like that, which we'll touch on shortly. What the NCC does, we do a few different things. First of all, financial support. We offer up to €1,500 for sponsorship, and that's for the event sponsorship. We also provide a lot of speakers and content for NOGs. One of the great things about NOGs is this network of people to disseminate information. And we have a lot of information as the Network Coordination Centre. So we provide speakers. We also work with them to provide workshops and training courses. And we also do, actually, we had one just before, sessions for the organisers themselves. So we have calls and in-person meetings to discuss kind of what's happening. So that is enough of me talking. We will move on now to the panel discussion, and I'll invite a few of my colleagues and friends up onto the stage. We've got Danielle, Jan, Angela, Barbara, and Branimir. I will get them to do the introductions because they're much classier than I am. Ooh. Just going to steal this mic. Wherever you want. This is where I live out my telly chat show host dream. So thanks for indulging me with this. We can move the chairs. So, as I say, the panel discussion today, we wanted to call it the future of NOGs, the future of network operator groups. But before we kind of delve into that, there's a question that I want to pass by the panel, and something that wasn't in the prepared notes. I always like to surprise people on stage. But I'd like to get your opinion on why you think NOGs are so important to the internet community. Why did you start a NOG, or what was the reason behind it? I'll open it up to anyone.
Okay, if I may start. Oh, okay. Thanks. So I think generally, like, people like to socialize, and in the professional world, you need a place where not only you can share your experience and problems, but also where you can let off steam. You know, where you can like tell your problems to people who actually understand what your problems are. So your router rebooted, and you needed like 3 hours for a software upgrade. That's not something that your spouse would easily understand unless they're in the same business. So I'm guessing not just this everyday stress, you know, we're handling everyday stress, and then we need to somehow to socialize, talk to people, let people know about the problems, let people handle our problems. So we're not the smartest people in the world. There are smarter people than us, and basically it's always nice to get a second opinion. So I think that's from a perspective of the creation of NOGs. So I think the main reason of the NOG is just socializing, talking to other people, and basically having a good time, in a professional environment, but still in a more relaxed atmosphere where you can share your thoughts and problems.
I also realised I didn't get you to introduce yourself, so Branimir, if you...
Thanks. I'm Branimir Reiter, so I'm the chair of the Croatian NOG. So we've been, I think, 3 years old. We have really good support from RIPE NCC. Alastair, thank you once again. And yeah, we've been part of this community not so long, but we feel very welcome, and thank you once again for the ongoing support.
Yeah.
Okay. Hi, everybody. I'm Barbara Angelus, and I represent the Hungarian NOG, Sohu NOG. We are, I think, one of the newest NOGs. Our first one was 3 years ago, so this year will be the third one. And actually, I'm working for the local CCTLD, so for the .hu registry, and we organize it together with the Council of Hungarian Internet Providers.
Yeah.
Okay, hi everyone, I'm Angela. I think everybody almost know me. We started the own NOG in 2014, and actually it came up not as an effect or upon the request of the community, the local community, but as a suggestion. Somebody recommended us. It was EuroX meeting in Romania. And they just asked, do you have a NOG here in Romania? No, we don't. You should have. So this is how we started. So somebody recommended us to have a NOG, and then we shepherd each year a NOG, a new edition of a Romanian NOG. It's not difficult, it's lots of hell difficult, because if you don't shepherd each year, you will get in the end like a short going out over a beer and talking with friends about how we're gonna solve this small problem. So just to have like good content, good agenda, you need good speakers. To get the good speakers, it's a little bit difficult because most of them are attending so many events all over the world. So you have to also timing with other events, not to clashing with other events in the region. Also, support of the sponsors is very important, because somebody must pay for the beer, correct? So we have to pay also for the meeting room, and everything costs us money. So, but in the end, everybody is asking us, hey, when is the next edition? We love to come again. Yeah, but do you want to be part of the community and do some work? Come along, we need your support, let's do something. Oh no, I don't have time. This is the most challenging, really. So people want to get involved, but they don't have time. So guys, if you want to give us a hand to everybody, so in your local communities, please do it. Because we cannot do it without your help.
Yeah, I think that's a really valid point, and something we hear a lot. I mean, just out of interest, everyone in the room, who here has been to a NOG event or is active in a NOG community within your country or region? There's one, two, oh, okay, so there's a few, yeah. No, I think it is true. I think one of the challenges, and we'll touch on it in a bit, but the finding people to check presentations, to help organising, all of these things all take time, and everyone's busy. So I know it can be a challenge. Danielle, I don't know if you've got any. Oh, Jan.
We're in the introductions.
Oh yeah, intros.
Jan.
I'm Jan.
Everyone knows Jan.
Yeah, thank you.
Not everyone knows Jan. I think we're on the false assumption that everyone knows everyone.
So I'm Jan, from Slovenia. I'm the chair of the CNOG, that's a Slovenian NOG. We started in like 2008, 2009 as the IPv6 summit, where we built the community. And then when IPv6 was not that much interesting anymore, it became an old story. We basically transitioned it into a NOG, so we opened up the area for also other topics other than IPv6 that are interesting for the network operators. And at the beginning, so why we built it to start IPv6 rolling in the country. But then my experience was that people that came from different operators were looking at each other at the coffee break like this and didn't talk to each other, because usually operators talk to each other through lawyers, right? But then through the meetings, through years, they became friends. And then you see one person this year works for this operator, next year works for a different operator. And then they start to understand that the title is not important. It's all about people. And then the music to my ears is when at the coffee break I hear the chatter, people talking to each other, sharing experience, and all this stuff. So this is the music to my ears, and that's why we have NOGs, to put people together. Thank you.
So I'm the last one. I chose to be the last one because I'm the strange person in here. Because my name is Daniele. I'm from Italy, so just partially from the southeastern part of Europe. But I'm involved in the Albanian NOG because I work for an internet exchange point, which is based in Rome. But since several years, we have started supporting the Albanian neutral internet exchange, which is in Tirana, in Albania. And so to answer Alastair's first question, why is NOG useful? For an internet exchange, the community building a network of network operators is essential, because we're all about peering, all about interconnection, and having a community is essential. So actually, the first event we organized, we invited Jan. It was in 2017. And Jan was extremely convincing to try and set up, to ask Albanians to set up a NOG. And actually this started and they had a first event, but the person who was in charge of the NOG for personal reasons left Albania and went to work in Germany and then the US. So this kind of fell down a bit, and at the last internet exchange event, we tried to, kickstart this thing again. So in lacking a better person, I'm trying to, start something up again, and hopefully next time there's going to be an actual Albanian member of Alun here.
Yeah.
Just adding something to Jan, because I didn't answer to how we started our NOG. When we thought about organizing our first NOG, I called Jan because I was totally new in the industry, and I asked him how to do it. And he explained me that usually these NOGs are evolved from a beering, so from a natural organization, people coming together, having a chat. But I told him that this is not the case in Hungary, but we, as the professional organization, actually organized the NOG, let's say, from above. So we immediately reached out to 100, 150 companies, and we initiated actually a NOG the other way around. And now we are trying to do some smaller meetups, so to go back to the roots, actually, and to organize maybe beerings or other events like that. So, but here I would like to say thank you for Jan for helping us to set up the Hungarian NOG, because without him I wouldn't have been able to do that. So, thank you.
Yeah, well, it was a pleasure.
Okay, I think it's great, and I think it's very important what a few of you have said is in regards to how important that community is. And how do you see, with NOGs where they are now, how do you see them adapting to the changes in the world in general? I mean, currently, I know, Danielle, you in Italy, there's a lot of smaller meetups and things. Do you feel that that's the way NOGs are going to change? Because, as everyone said, it is not cheap to put these events on. It involves a lot of work, it involves a lot of time, a lot of sponsors, all of this stuff. Like, are they still fit for purpose? I mean, I know obviously they're incredibly important, but do we see the way they're changing, or do we see a way in which they're changing?
So what Alastair is referring to is that in Italy is a big country, and there's 60 million people. It's a long country. Distances are huge, can be huge. So there is an Italian NOG, and there's actually a representative of the Italian NOG there. And there's a national meeting every year with how many hundreds of people participating every year? 400 to 500 people. And some people in so this is organized in Bologna, which is rather central for transport in Italy. But some of the less, more decentralized places have thought that it would be nice to organize more local events. There has been a local event happening in Milan, so let's say the best place for internet in Italy for 20 years now. Yeah, and this is just, we have dinner and we have a beer, and everyone pays for themselves unless there's someone who wants to pay for the event. And now these kind of events are popping up everywhere in Italy, and there's probably about 10 or so. It's on the ITNOG website. Of those local events, and it makes sense when you're a large country, because then you have a more local place where to meet, and maybe you meet more often. It's a different concept though. So where are we going? I don't know. I'm not sure. But clearly in Italy, we are going towards this kind of decentralization at the moment.
Anyone else? Thoughts or inputs on that? No? That's cool. I mean, you've mentioned challenges and things like how can NOGs maintain relevance and adapt to changes in the networking landscape? Things like automation, AI, security challenges. Like how do they help with adapting to all these fast-changing technologies that we see coming out?
Well, it's not the question of keeping the relevance. NOGs are NOGs. They're just there. It needs to be organic, right? The growth needs to be organic. People come together and talk, because just with having NOGs, you keep the relevance. And also, we found out that a good mixture of international experts and local knowledge is crucial, because we, for example, I still consider Slovenia part of the Balkans, and in our culture, it's sort of like people would rather listen to some international expert rather than a person from their own country, right? So it's a good thing to have also some international experts coming in and sharing their knowledge.
I think NOGs are relevant in a way that for a young engineer who is just getting into the field, it's a really good opportunity to meet experienced engineers, to see what is else out there in the networking world, not just to be focused on your little area of expertise. The fact that there's not a lot of young engineers anymore is another topic, I think, for another panel discussion, I would say. But I think the relevance of the NOG is basically in the exchange of the knowledge. So basically, NOG is a really good place where not only you have people from your own company with which you work every day, but you get to broaden your horizons to see what other problems people are solving. You can get to talk to other really good engineers, and really you can get a way to expand your career. Not only, most of us don't work in the same company their whole lifetime, so it's always also from a career perspective to get to know people in different companies, to see if they're maybe a good fit, how their work suits you, etc. So it all, in the end, it always comes back what we were mentioning at the beginning, so networking, mingling, talking to people, etc.
Just want to add, because Alastair, you were asking about the challenges, right?
Yeah.
So one of the main challenge, I think, for the Romania, for the local NOG, is getting the young people involved in the NOG. So most of the people attending the NOG are experienced ones, so all technicians. But we just want to get involved in a new generation, the young people, to come along and share their experience, or probably just to ask questions if they have some, or to learn from the old farts. I'm sorry, guys.
All of us included.
Yeah. So what I'm saying is, I don't know how we can make them, how we can motivate them to come to attend these meetings, because there is a lot of work behind all the presentations and very interesting things that might help them to shape their knowledge, technical knowledge and everything.
Well,
not sure how, because we tried many times to address to the university, to every, I don't know, associations of young people, enthusiasts, whatever, nobody is attending. I don't know how to do that. We also motivate them, please, we have also an award, or the most interesting presentation will get an award. We can also pay for a very nice presentation. Nobody is coming.
Well, we hold a meeting at the university, basically. I've seen the gap in approximately 2 generations. There is a gap in between the older, more experienced experts. But now I can see the new generation of engineers coming in, because we reached out to universities, we reached out to professors, to teachers, that they start teaching them also not just about the protocols and the networks, but also about the community that is surrounding, and then that's how they get interested and not just writing a mobile app and get rich.
Adding something to the university and students' questions, what we do, we invited 2 members of 2 different universities to the program committee, so that they are more involved, which I think was a great idea, and from the program committee. And also we encourage young students and offer them, or university students, and offer them free places to attend HUNOG, because otherwise our conference is not free of charge. And each year we encourage students to come and take part and get involved into the community. And speaking about the challenges, I'd like to add that in Hungary, there are many small companies, local ISPs, and for them it's also a challenge to come away from their work, from the office, and take part at the conference. And also, it's interesting for sponsors. People are open to sponsor the event, but they not always have enough staff to fulfill the booth, or to give staff for the booth for 2 days. So sometimes we feel this challenge, that they just don't have enough, they're short of staff. This is just one of the challenges that I would like to add.
More to add, our NOG is free of charge. So there is no participation fee for 2 people from the same company, because we try to limit the sales force, big companies sending 10 people. So
we are free of charge for everybody, be that.
I will say, if there's anyone in the audience who has any thoughts or comments on any of this, please feel free to jump up onto the mic. This is an open session to all if you have questions or even thoughts on how can we attract younger people into this. Is it a case we go down the meet-up routes, which are normally in the evening and a lot more social? They're a lot less hard to get time off to go to. But I think it's definitely a valid point that we see. Not just with NOGs, I mean, we always struggle to get junior and young people engaged with the community. Unless they're, I mean, don't get me wrong, they exist, but it's normally a small amount as opposed to a larger, and finding ways to do that is increasingly hard.
On one hand, I agree that evening beerings or evening socials and smaller events are have less impact on your day job because you don't have to ask permission to anyone, but they have impact on your personal life. So usually the people, in my experience, the people who come to those kind of meetings are actually more committed to the community, are more interested in meeting the others, and often are already part of the community. Maybe it's even harder to get newcomers to this kind of meetings because it's like you're invited to a party where you don't know anyone. So unless you have a friend who brings you there and says, okay, come to that party, you'll have fun, but that's an additional effort that we'd have to make.
Anyone else? Okay, so I mean, we've looked at kind of the challenges. I mean, is there something that we, as the greater community, could be doing better when it comes to engaging with NOGs, or do you think it's I know a lot of people have said it's a very organic thing, the way NOGs grow and the way people find out about them, but is there stuff that the community should be doing to try and help? I know you've mentioned it's often hard to get people on the PCs or people to take part. There's often a lot of people who say, oh yeah, NOGs are great, they're amazing, but then when they're asked to actually do stuff, the mail thread goes quite quiet. So what do you think can be done to encourage people more? I know that's $1 million question, so if anyone has the answer, you'll be set.
Please come on stage and tell us the answer, because as I said, I've been looking for a while for an Albanian person, a replacement of the guy who was the lead of the NOG. But usually, I don't know about you guys, but usually NOGs are led by 1 or 2 people, not the local champions, as Jan says. Not the larger NOGs. I know that IT NOG has, I would say, 4 to 5 people, but smaller countries, it's hard to get even one person. And why? Because people have day jobs, people have families, and NOGs, and this was pretty fun because Laura from the RIPE NCC asked me at some point a question that I had never asked myself. Is anyone getting paid for this? And I think no one's getting paid. I don't know anyone on any NOG who is getting paid anything. Contradict me? No. Arnold? No. But maybe in Germany, I don't know.
So I'm Arnold from DKIX. But as far as I know, the PL NOG is very commercial. Yeah. So and I guess there's an organization behind it who is paid, which are paid. So.
Yeah, I believe so. I mean, this kind
of... PL NOG is, they come together, are thousands of attendees.
This is one of the things that, when I mentioned earlier, there's NOGs come in so many different shapes and forms and sizes, and there are fully commercial entities that running a NOG is their business, and they have these, and people get paid. But then there's these volunteers who are just putting a lot of time and effort in to provide space for the community. Now, as the NCC, we don't get to dictate what is a NOG and what isn't. But I think it's interesting that regardless of what a NOG looks like or what the issue is, the problems are the same for pretty much all of them. I mean, getting people to attend, getting valuable content, getting interesting information is always going to be a challenge. And I don't know what can be done, because I feel I always look at the NOGs, the RIPE community is this behemoth of a community, and I always think of NOGs as individual little RIPE communities in each country, and each country needs to be dealt with differently. There's different ways in which policies passed and all of these things. And I think that's one of the things that why, for me, NOGs are so important and why I would implore anyone in the room, if you are able to help out, because it is an incredibly intricate part of the greater RIPE community in the internet ecosystem. Sorry, I went off on a tangent then.
I would also like to add, like, I think I speak for all of us here when I say that we get positive feedback. You know, people want to participate in NOGs. They get.
Sorry.
No, just to add. So also for DNOG, I know this is meanwhile really a professional 2 days event, and the organizers at least get compensated for the expenditure, which might be also a good idea for other NOGs. That at least the organizers, if they attend, they get the hotel for free and so on and so on.
Yeah, well, I just wanted to say that, like, what we get from the feedback from people who attend NOGs is that they feel they are getting something out of it. So they have positive feedback, they are willing to go to the next NOG. So it's a bit of kind of, let's say, contradictory and maybe ironic that nobody wants to be more actively involved in it. So, yeah. Yeah, so.
But people come in flocks when you organize a meeting. I mean, you say there's a meeting, like when, where, I'm coming immediately. But as Alastair said, then as soon as you say, yeah, well, will you help me organize the next meeting? Well, yes, I have other things to do, which is fair. But then again, how do we solve this problem? I'm not against paid people, but paid people means you have to have a business case, which maybe in Poland, yes, but maybe in smaller countries, I don't know.
I don't think so.
I'm sure many people would like to get paid, but
yeah,
please.
Hello, Zoran Perovic from Serbian Open Exchange and IXP in Serbia, and also organizer of NOG for 10 years. In Serbia, it is organized by CCTLD and by IXP. Those are natural focal points in Serbia, and we have no problem inviting people. We did have problem financing. Initially, we financed it half-half, but 10 years later, we roughly give 30%, and the 70% is given by sponsors. We are very, very determined not to have commercial presentations, so it is a bit difficult to take people's money and not give them the commercial time slot. Sorry. Jan, thank you for bringing the sun. I asked 2 hours ago, and here it is. Yeah.
I send the fax.
You send the fax. Okay.
Send a fax.
The thing that I believe is an elephant in the room is networking is no longer fancy. It took me 6 months to earn my first flat back in the 2000. I worked for Ericsson during the dot-com boom, and the rates were ludicrous, and it was easy. Today, it would take me more. Today, young people are not so into networking, as Jan said, 2 generations. Maybe new people, new engineers will come. We will hear that later, right, on one of the topics. But I don't see it coming. Maybe with 5G, I don't know. But as you ask a million question, what is the $1 million question? How can we motivate people to come? We need to keep listening to the community and pivoting our path. For example, we started with very advanced presentations, only to learn that the community is not responding very well. It's not something they will do in next 6 months. Then Jan, also part of our group, gave the presentation on Anycast last year. And it was like, yeah, Any, what? We don't really need it here. Maybe CCTLD will do it, but not a lot of interest in the community. We brought people from Cisco, we brought people from PCH, from ICANN, talking all kind of stuff, but then listening and adapting the overarching theme of the RSNOG is the key. So every year it's different.
Yeah, thank you. I mean, there's a few points I'll touch on, and maybe Dimi, I don't know if your point's relevant to the one that was just given? Because I'm thinking, you mentioned a few things, and I know on the panel there was a comment about the challenge of content versus sponsored content and what the community wants as opposed to what enables an event to be put on, because as we've mentioned, none of this is free, and sponsors want sponsored slots, but then attendees don't want marketing pictures. So I think it's a real challenge to find that kind of equilibrium of what works and what brings money in. Yep. Is that a question?
Oh.
Yep.
Yeah, sure. It's not going to be a long-winded speech. Discuss it as a question. I would like to thank the panel, and well, as the previous person mentioned, yeah. Sorry, Dmitry Kokhmanyuk, hostmaster at UA Ukraine. I'm sorry for not saying that first. I think the networking got fancier. It just hid itself into the data center, into the cloud, into the 5G, into VPNs. I think it's actually been the hardest than ever before. But I think, yes, the typical ISP can be done on the chip, and you probably don't have a resource for doing like CLAT server installation in a mom-and-pop company, which has a staff of like 5 people. That's true. And if you want to work for Facebook, when it's IPv6 only data centers, it's really fancy stuff. Well, you have to go work at Facebook. So I think the gap is that between the haves and have-nots is widening. But I think in the Balkan countries, it's still possible to do fun stuff. Let's see, what's the company from Romania who does its own DDoS protection? You should know that name. Yeah, Vexility. I'm sorry, guys. Yeah, I know you're here. I'm apologizing for not. There are others. I live in Vilnius now. There is a NordVPN, which, by the way, still don't do V6 properly. Yeah, thanks for the talk. There are many things to be done. It's not simple at all. And yes, it can feel frustrating, but like at this other project showing, the one is trying to compete with the RIPE project of the router, which is, by the way, semi-dead because the tourist router is sold, but I think the development has been pretty much closed down. It's a challenge, but I think we should go wider, involve more people. Like I said, the cloud still has networking. Have you tried to set up V6 VPC on Amazon? It's very interesting. I don't want to say other word that I thought I would say. It's never been a best time to learn networking, but yes, people don't learn networking because they learn Docker with its budget up V6 net. What can we do to make people interested? That's an open question. We have RACE program. Students and the regional events do help. Thank you.
And I guess that kind of leans again back on the importance of NOGs, because these are areas where people, it's an easier entry into than a big RIPE meeting or an ICANN meeting, which is normally in a far-flung place in a 5-star hotel. These are a lot more local, and I think that emphasizes the importance of NOGs with education and knowledge sharing. Yeah.
Indeed, for example, in Hungary, what we were facing, not everybody speaks perfect English, let's put it this way, which I think in our countries is pretty much the same. And so language barrier was kind of a problem, and also that people were not so much open to travel. So when they looked around at the international conferences, you wouldn't have seen many Hungarians. So that was also one of the aims of HUNOG, to bring international knowledge to Hungary. And then, of course, the problem comes with the language. So which language should it be? If we have international speakers, will Hungarians understand it good enough? So language, I think, in our countries, in each of our countries, I think, is an issue. But just one more thing to add. In Hungary, we faced that HUNOG was so much gap filling. This is what was coming from the feedbacks, that people were eager. They were hungry for personal meetings. They were so much missing it that this is what comes from all the surveys, all the feedbacks, that they want to meet in person. And I think that's why we are all here, because we didn't just want to meet online or see that much of each other, but wanted real reactions and real conversations.
So I will just add something
about the language, then I will let Tomaz ask the question. So our meeting is not in Slovenian. Our meeting is completely in English because at the beginning I started because we usually have international guests coming in. And my first demand was every presentation slides must be in English. And then Slovenian speakers, Slovenian presenters usually ask me, should I speak in Slovenian or should I speak in English? And my classical generic answer is, if you will speak Slovenian, majority of people will understand you. If you speak English, everybody will understand you. So it's up to you, right? And also for the recordings that are on the website and everything else, so other people from other countries can also see what's going on in our country and about the presentations, then it's better it's in English, sorry. But Mr. Chair, should we let him ask the question?
Absolutely. Hi, Tomaz Zaman from Slovenia. So I didn't come to ask a question, but rather to share what we did in WordPress community, right? So we learned that people were much more willing to attend to speakers that told great stories, right? We evolved as humans through storytelling, so it's much more interesting to listen to somebody who tells a great story rather than is a fact giver, which a lot of very technical people are, right? So what WordPress community did is they saw who is more of a fact giver kind of type, but they opened it to everybody, so they organized public speaking workshops. They don't have anything to do with WordPress itself, yet when we got there, it was a lot of fun. People would talk, practice to one another, eye contact, what to do with arms, what to do with their bodies, right? So it's a complementary skill that we all learned, and I've been to several of those, and they were always super fun, and we always learned something new. The second thing we did was we did live coding in front of people or on our own computers. Right? So we sat down and saw, rather than watch somebody do it, we saw the results of our own work and we felt happy about it, right? So that's what WordPress ecosystem did, right? So we were much more involved rather than just passive listeners, right? And as final perk at the end of the day, if all else fails, free booze always works. Thank you.
Thank you, Tomaz. But you know that not all the speakers are speaking freely, and some of them are shy and are not that expansive and so playful like you did on stage. So sometimes it's very difficult for us. In Romania, we have also translation. English, Romanian to English, but also we prefer English speakers and English presentations. The problem is that most of the content is done by the international speakers because the local ones are shy to be on stage. That's the problem. So it's difficult to get content from Romania because we have probably good presentations, but they said, no, I don't feel well to speak openly on public, on stage. I'm a little bit shy.
Yeah, I think that's actually quite an interesting take, because the language thing, because the NOGs are for the local community. I know that the international speakers are great, and it's cool that you accommodate, but I think there's potentially a bias that everyone assumes everyone's comfortable in English nowadays, and it's not the case. Even more so if you are publicly speaking, and I think that can be a real challenge, because obviously you want international people to attend, but the NOG is for your local community. And how do you kind of weigh up the pros and cons of that as an organizer? How do you say, okay, we are definitely for Hungary, let's take Hungary, we're for Hungary, so Hungarian is the main language, and if there's an English speaker, then so be it. So I made eye contact with you then, Barbara.
No, it's interesting. So what we did, we had approximately 80% local presenters. Not easy to find them, as Angela said, and also I think the knowledge is there, but as you said, they are shy to go onto a big stage and present it, and also they're not sure if their knowledge is interesting for the community. So to convince them that yes, what you're doing is surely interesting, this is one thing, yeah. I don't. What was the other?
The language, like
the language, yes. So we had approximately 20% international speakers, like you or you, and as you said, people understand English. They okay with it, but they were not so comfortable that they would travel to another country, for example, and to mingle and network in another language. Of course, the presentation they would understand because the language of IT is mainly in English. So this is a challenge, but this year we will most probably translate, so introduce translation and do it in double language.
I mean, if I could, before I let Ulrich speak, I think also the real, like we've done surveys to NOGs before, and the thing that really stands out as the most important reason is the networking aspect, not the presentation. So a lot of the times, whatever language the presentation is, the core benefit of the NOG is what's happening in the hallway or at the bar. So there, I guess, the local language is always going to be prevalent. Because I've been to some where I'm just like, I don't want to make everyone speak English, so I'm just going to stand here in the corner. Well, I very rarely hide away in the corner, but but yeah, I mean, it's definitely a challenge. Ulrich, do you have any? It might not be about this, but over to you.
Hi, I'm Ulrich from ICANN. Well, as one of those speakers that, traveled around and speaks, I would like to say, like, fuck me. I mean, I'm there for your community isn't there for me, right? So speak your local language. That makes people more comfortable. Do that. And to make people more comfortable to speak, I would like to give a challenge to everybody on this side of the house, because there's nothing more encouraging for a speaker than when you come after the talk, go to them and say, hi, good talk, really nice that you went up on stage. You don't even need to say anything more. That's all they need. People will be, happy for the next 2 weeks. So it's actually, to the participants, this is really, really important for the speakers, and it makes more people to participate. So if you like your local meetings, encourage people to speak, and so that's your job.
Yeah, I just wanted to add, because just before Ulrich, as you said, people love to stay networking, drinking, let's have a chat. I think one of the most successful meeting is the one with the longest coffee breaks. You see, because usually people are eagerly to talk to each other. So I'm really considering to extend the coffee breaks, because I'm all the time we have to chase the people. Okay, people, please go inside the conference room, because speaker is already start talking. We are behind the schedule, so and it's not nice. I think most of you who are speakers, it's not nice to stay in front of an empty room talking to whom. So people are not supposed to stay outside.
So why are we having presentations then? Let's have one big coffee break and be done with it.
Also considering that. Just 3 presentations, one in the morning, 1 hour break, and then only 1 presentation, and so on.
We have to have an excuse for the sponsors, that's the reason.
Yes. No, and for the employers, that, because people are, they have to convince their boss that it's useful, and it's very hard to say, I'm going to this place, I'm going to meet people, which is actually the point, but bosses are not easily convinced by that. They prefer to hear, I'm going to a serious conference, and there's important speeches and speakers. But this is the world we live in, so we have to kind of balance this with good presentations and long coffee breaks, yes.
But I must say, like what Alastair said at the beginning, like the presentations are necessary, but like the feedback we get, like if the presentations are good, nobody cares. If it's great, it's an added bonus which nobody counts on. So it's just about the networking, getting that beer after the presentation, you know, after the meeting.
Yeah. Andre?
Andre Tsahatka, RIPE NCC, and in this case also CSNOG. Regarding the coffee breaks, yeah, it's really hard to get people back from coffee breaks, and always the first talk is like, yeah, there are a few minutes out of it. But from my experience is that no matter how good discussions are there during coffee breaks, if you just put only coffee breaks into schedule, people will not come. So you still have to put like scheduled talk with some topics, because that is what will bring people in. People will not go just for the coffee break. So it's just like, it's really hard to balance, you know. Also, and the other thing that, well, speaking from my program committee experience, I find really hard is that then you get to the state where you have like N presentation and you have like M slots, and then you figure out, oh yeah, maybe if I actually shave this coffee break a little bit, I can accommodate more talks. I will take 5 minutes for every single talk, and they will just, I will just not need to refuse a talk just because of lack of time. And this is sometimes really hard because, you know, if you have like good content, you don't want to just refuse it because you don't have time. So you try hard to find room, and then it might get a little bit more like intense, let's say.
If I may just add our experience, so we actually, our conference has, our meeting has like 6 presentations. It's like an afternoon event, and each presentation is a maximum of 20 minutes long. So we just want to give people like enough so they can like chew on and ask the presenters later on if they're interested, and if somebody doesn't like the topic, not to get bored by it. So we tend to like to have shorter formats of presentations, a longer coffee break, yeah, and then we go to a bar afterwards, yeah. And I think the bar is the most important part. But yeah, maybe people hear something interesting from presentations. Maybe they talk to the presenters afterwards because it's interesting for them. But also, if somebody doesn't like the topic, they can quickly move on to the next topic. So I think, in my opinion, it's a good compromise.
Well, I know we only have a few minutes left, so I'll go down the queue. I missed all the questions I was supposed to ask, but that's how it normally works. But the last thing, my question card says, ask panelists for their key takeaway message for the community on how to support the future of NOGs. That's a very, I feel like everyone's going to have the same answer potentially, but yeah, how can the community as a whole, what do you need from them? I know we touched on it earlier, but if you could have one ultimate thing that you got from the community, or what they could do that would help with NOGs and continue their importance in the community. Barbara?
So if we promise to make shorter presentations and longer coffee breaks, would you promise to give your thoughts to the community, your energy and your enthusiasm, and give presentations at NOGs? That would be my thought.
Well, to be honest, we don't have major problems. So I will just keep doing what we are doing for the last 15 years and just keep doing it, I guess. And thanks to the RIPE NCC for supporting and sponsoring all the NOGs. This is for some NOGs it's crucial part of the sponsoring, so they don't have to ask more commercial sponsors for it. And thank you to ICANN also for similar support to all the NOGs in the region. Thank you.
I would just like to build on what Barbara said. So I think what would be most important for us from our organizational standpoint is to get more presentations. Not to have to drag people, you know, oh, can you do this presentation, can you do that presentation? People are experts, people are good experts, and we want them to share the knowledge. Even though they might not be the perfect speakers, we want them to get up on the stage, share their experience, share their problems, how they solve it, and I think the community will be better for it.
Guys, please stick with us. Thank you.
So if you are here or if you're watching the recording, that means that you care, you're interested. So, consider collaborating and do anything, basically, even just a presentation or just a hand with moderating the mailing list or whatever, or introducing a topic in the Telegram chat, or I don't know. But, the community is basically you, so it only works if you participate. If you don't, then maybe you don't need it.
No, absolutely. I think that's...
Or maybe something is wrong, because when we see each other, means that we are all good, yeah? When we don't see each other, something might be bad.
Yeah, and also to touch on kind of from the organisation, if you are able to give any time at all to your local communities, be it mailing list moderation or helping with organising the event, anything at all, I know that a lot of NOGs will be very appreciative of that. I will just say thank you so much to my wonderful panellists for joining me today. I have inevitably forgotten something that I was supposed to say on stage, but if there aren't any questions at all, I'll open the mic queue up for one last second. And we're done. So thank you everyone for joining. Thank you for your participation, and find me for a drink afterwards. Group shot. He's gone. He's off. Big step. Very awkward with all these people staring at you. Love it. Thank you very much. Thank you so much. Oh wait, I stole the moderator's mic, so. Thanks.
Now we're starting, so with my session chair hat back on, so we're continuing with the lightning talks now. With us is Gianluca Sironi, so he'll be talking about football.
So, talking about football. So, how's it? I use this one. Okay. Just to tell you shortly what we are doing, we are gathering and collecting traffic measures. You'll see where. And I want to tell you something about this focus on football. Being Italian, it's quite natural. And they focus on the Champions League because it's on Wednesday night. So I'm from La Quadria, it's not important, just we run an internet exchange, which is a small internet exchange, but it's not part of the story because we don't have access retail. So we see, for example, the Microsoft Patch Tuesday traffic, not the football traffic, so we can move on. I said focus on the live sport events, not all the sport events, football, not all the football matches, but especially the Champions League, and in the Champions League only the one streamed Wednesday night, because it is streamed exclusively by Amazon Prime Video. So it is only, let's say, one place. It's not a simulcast or more content provider, so it's easier to measure. We have measured starting from end of 2023, so we have a lot of matches you will see. Let's go quickly. Traffic statistics, mainly from Namex and the Minap. Namex is the exchange of Daniele that told before. Minap is a neutral access point in the XP Milan. The order by traffic, the first one is Mix, but Mix expose graphics but not publicly data. Instead, all the other publicity you will see with based on XP Manager in a JSON format, so very easy to fetch, to collect together. And one note that will be clear later, Amazon is a member in Namex in Rome and not in Milan.
It has a consequence starting from September, you will see quickly. Where we get data, these are a lot of XP based on XP Manager, because it's exposed this API, and you see the data in JSON. We collect all this data sample every 5 or 10 minutes. It's not really important because they are the 5 minutes average published. And we do a lot of things with this statistics. We can compare traffic, compare week to week, day to day. We can normalize, then compare exchange to exchange and so on. But let's go on. For example, this is week 9, which is a couple of months ago. The days are normalized to the weekly average, and just a focus on the prime time. There is not a unique definition of prime time. We are trying to measure the span between 9 and 11 p.m., which is exactly the time of the football matches. So that's why we are trying to define these new variables. The other exchange, not important when you have the data want to compare. This is, for example, gathering always economics weeks. And you see the pattern is quite consistent. And this is Saturday and Sunday. Sundays have more traffic than Saturday, and you can find matches by matches following the time frame and the week. But let's go. This is an example to compare traffic of different scales from different XP, normalizing. This is a very simple min-max normalization. Just to underline that Wednesday and Sundays are the most interesting days, usually with the most, the matches with the most traffic. And let's say now the presentation has a focus on Wednesday, but we are doing similar work for Sunday. Another source of information is the PeeringDB. There is Livio down there, will be an update in minutes. The red one is NAMEX, which is growing. Also, their traffic is growing. And the blue line is MINAP in Milan that is quite stable, but never mind. This is the boring list of the matches. The important thing, or the funny thing, is that quarterfinal and semi-final last year were without Italian teams. Nevertheless, there was a lot of traffic, you will say it. This is the running competition, the first phase that is called league phase, starting from September up to January. And these are the running knockout phase, the last matches. In gray, there will be one next Wednesday and then the week later. So, of course, I don't have the data. Difficult to have data from Amazon. This is the only official source, come from the Italian government agency. We have tried to ask to Amazon to give, let's say, some gathered information, not detailed, but no answer at all. So we have to move with the only data we know. We are trying to introducing a new variable. You remind that we are trying to define the prime time. This is supposed to be the prime time average, which is the shape is relatively flat during that period. So you see the 95 percentile, 95th, and the prime time, they are very, very close. These are two examples, but I want to share this one. This one is both from MINAP and NAMEX. You will see that the line, for example, for NAMEX, the red and the purple are practically overlapped. And there is a psychological threshold, 1 terabit per second, they reached some weeks ago. And but in this stage, we are still using the 95th percentiles. Once it will be more consistent, we will try to define better and use this prime time average. This is MINAP. Last year, the first stage just underlined that some matches, for example, the semi-final has a huge spike of traffic compared to the rest of the week. If you pick, for example, the week 17, the week 20, or the week 21, Wednesday and the rest of the week are very similar. A week 18 and week 19 are completely different. What's happening after September? We have, you reminded that I told that, I have to rush because I go, this is the yearly view of NAMEX, and a focus on the, you see all the spikes are exactly during the Champions League matches. And again, this is running competition. Again, the spikes are always on during the matches. This is NAMEX the same. This is NAMEX, just a note that luckily Christmas is down. Maybe people are doing some other things with family instead of following matches on TV. This is the running competition, the last weeks. Interesting that this is the first time they reached the 1 terabits. Again, reached a couple of weeks ago. And then, even if there is a pattern of traffic growing, the Champions League matches are always the top of the, not only the weeks, but of the rest of the time. This, personally, I consider it a vanity metrics. This is the all-time peak. It's not the 95th percentile. For example, this is last year. On 7 times they reached the new peak. 6 times was during Wednesday UEFA Champions League matches. Again, this year, week 3, there was an important Italian league matches. The week 5, which is the last all-time peak, is during a Wednesday Champions League match. Interesting example. Same slot of weeks, from 8 to 12, comparing last week to this, last year to this year. What's happening? That the pattern is quite similar, but there is a, let's say, at least a 50% increase of the traffic, not only during the prime time and during the matches, but also during the day. You can pick the time you want. Same for Sunday, but very similar. Just a note, on the left, there is something that we are seeing in Minap. Said Amazon is not appearing in Milan. Stop. So the CDN choose to drop the traffic, and I drop my presentation because it's over. Okay. Sorry, but during, let's say, another meeting, it was a 30 minutes presentation. I have to shrink in 10, maybe less.
So there's a big problem with criminal organizations stealing the real life, the stream and submitting.
Name, please. The name and affiliation, please.
Yuval Shavit, Tel Aviv University.
Yeah.
So they are stealing the signal, resubmitting it to a huge amount of people, and I wonder if your data can actually capture this, because you are geographically spread.
Yeah, only partially. You see that, for example, in Minap, there is a good transparency. All the members can see the traffic of all the members. I can see, for example, this kind of drop, also so the increase for an access network or whatever. Not in another exchange. So we can ask, for example, the usual CDN involved if they see coming from a different source. Let's say suspect source, but they don't tell, usually they don't tell us. We have for example, talking informally with people at NAMEX, we say, there is a strange fact, we see a drop of 100 gigabits, and what have you seen? And they say, an increase of 100, exactly the same time, exactly on the same match of a CDN or access network. So, and I'd like, but should be a cooperation also from the access provider and the CDN. At this stage, we don't have it. We don't have it yet. Okay.
Thank you. Thank you, Gianluca.
Sorry for the rush.
Livio, Morina, PeeringDB updates, please.
Hi, I could go ahead with the presentation that Gian just did, but this is not a presentation. But if you are coming to Denver at the Global Peering Forum, I will talk about the Piracy Shield, the Italian system against the not allowed streaming services. But that's another story. My presentation is, I downloaded the last slide from the PeeringDB database, and I think I could speak for 30 minutes or more, but I have only 10 minutes, so I try to reduce a bit the situation and save the schedule. So, who am I? I'm Livio, Morina. I'm a board member of PeeringDB. I'm also a member of the Outreach Committee. And this is my email if you want this presentation, because I will skip some slide or I will go very fast. The presentation will be available on the website of PeeringDB, but you can also mail me and ask for it. A brief agenda of this presentation, some update about the elections that are going to start next week, or in 10 days, the 2024 for us, and also what's next in the 2025. This is the statement. We are an association, all maintained by, funded by the money that are coming from the sponsors. So we are volunteers, we are not getting money from the association. And I'm focusing on this slide because now we have the elections. So the board will be renewed. There will be 3 new seats, there are 3 free seats, and now the nominations are open, so you can also submit your name. But I want to focus on this. Today there are 30,000 registered organizations, so 30,000 votes that can be cast. The point is that only 497 network organizations are registered to vote. So we are talking about 1.6% of the organization. I hope that we can increase a bit this data, but it is not up to me. It's up to you. So if you want to join and support the community, it is the same topic as the NOGs, the panel. We need to put effort. So I decided to put effort on this, and it is not an effort so strong. It is just cast a vote and take a look at the mailing list, government mailing list. Last year received 9 emails, so we are not talking about spam or huge lists. On our website we have a lot of how-tos, so you can learn how to use PeeringDB, but also learn how to participate and learn how to be a member of PeeringDB at various levels, be a member of the board, be a member of a committee, and so on. The elections will start on the 15th. And they will last for 15 days. During that 15 days, you will be able also to subscribe to the government mailing list. That is the way to vote. It is not the only requirement. You need to have an organization. So register to PeeringDB with an organization. And in that case, you can join the mailing list named Gov, and then you can cast your vote. Last year in Athens, I told you, when I've been elected in 2023, the voters were 121. So please, let's increase this data. Last year, 98. So it didn't work, but I hope that this year we can do better. So please, take a look and vote. The users in PeeringDB are all the users that are using the database. So no registration are required, and all are users. The members are organizations with the subscription to the government mailing list, and that's all. All the members can vote, can elect the board members, can do a lot of stuff and participate to the activity. These are the 6 board members today, 5 plus the secretary, and I am the one that is leaving. I am already registered in the nomination list, and let's see what will happen. In PeeringDB, we have committees. Every committee is made by volunteers, for sure. And there are also departments. So the admin committee is the one that is answering you to the tickets. So when you have an issue, when you have a request, it is the committee in charge of this task. The operation committee is deciding and managing the database, because the database requires effort to run it. The outreach committee is holding meetings and organizing the post on the social and all the activities related to the topic. And the product committee manage the roadmap, so manage the development of the database, of the new features. Just a note, the database, so the features are every day can be more and more. It is just up to you. You can submit your ideas. I'd like to see PeeringDB with these tools, with this function. You just have to log into GitHub and say, oh, this is my idea. Is it possible? Please take a look also to the old ideas, because probably it could be already cast. In that case, you can say thumb up, I like this idea, and if we reach the consensus, the process is that we will take a look at the request. If it doesn't break the whole database, so we go ahead, we check how to do, we check what's the price to develop it, because we pay a programmer, an external programmer, and then we decide if it is okay or not for our budget. The strategic plan has been published some months ago, and you can download it from the website. We increased the budget for the development of PeeringDB. So once again, if you have ideas, this is the right moment, because we are taking care about that, about those ideas. These are the review, the data of PeeringDB 2023 and 24. We have an increase in every sector, so that's good. We have new future. We worked a lot. I have to go faster because I'm finished the time. A lot of improvement on the search, and if you want to know more about the search version 2, you can take a look at the docs. We also implemented a better PeeringDB PI. So PeeringDB PI is a system you can that allow you to download the database and run the queries on your database, local database. So you don't reach the query limit that can happen with our database. Every query means that we use computational computation on our provider, that is AWS, so we pay more money. So we encourage you to use this function if you are doing a lot of queries. We also integrated the KMZ on the for Google Earth. We also added a lot of details in the KML for GIS and so on. And we also moved to the containers, but this is a technical part that I skipped. The new objects, but they are not so new now, Carrier and Campus. If you need information about those records, I like to go deeper in those small bug fixes. But what's next? We are trying to run a test about the new interface. We tried to run a rollout process with volunteers, but no one was trying to use it. So we are now trying to push a mandatory test to users to see if we can get feedbacks and let it work better. Because it already happened last year that working in new versions will lead us to put a step in a manhole. So we have to be careful with the new features. So new features, also we want to add a planned record, so a company, an organization can say, oh, I'm going to peer in that exchange. We are also talking about if a date is useful in this case. There is a discussion, this link is on GitHub, so you can take a look and say your opinion. So we are developing it now. Please help us to develop as you'd like to see it. Once again, we are optimizing more the search, the API queries, and so on and so on. We also added in 2024, or maybe in the beginning of this year, the port location. So a network can declare an exchange. So I am at Namex, but sometimes a port can be remotely settled. So the information about the exchange without the location of the router that is managing that port can be not so useful. Now you can add also the information about where is located the port. But the main course of the presentation is the mandatory two-factor authentication. So from June the 1st, it will be mandatory. Don't arrive at the last day or the following day and say, oh, I cannot log in, I need to modify this record because Microsoft is not sending any more traffic, but I cannot do that, and you need more time to enable two-factor authentication and so on, and you will lose traffic. So please set up the two-factor authentication if you didn't, and this is very, very important. We are also adding a new tool that is helping to make comparison between facilities on the slide, but I think it will be available also for the internet exchanges. So you will be able to check on one side Mix, Milano, and the other side Namex, Rome, and see what are the networks present in one, not in the other, and so on and so on. So we are developing this part, and if you have some idea about that, please send us information. Let me close. I want to show you some data. Thanks to Arnold that provided me this list. Where is Arnold that I saw at the microphone before? Thanks, Arnold. Arnold is the guy that is extracting the data one by one, right? Or just a click? Just a click, probably. And these are the information that we have in PeeringDB. I cannot go so deeper in the description, but I want to show you and point the finger in the column PeeringDB RIR. If you check the first one, Albania, 42 are the networks present in PeeringDB with the Albania tag. But in the RIR, they are 128. So we miss data. We hope that we encourage all the networks to join PeeringDB because the quality of the data are very important for us. So I hope that we will be able to provide a good service to the users that will access to our networks. As I stated at the beginning, we are maintained by the sponsor. These are our sponsors. So please, if you want to become a sponsor, ask for information. I'm here, and I am over 2 minutes on my limit. Thank you.
Sorry, we're short on time, so please take questions to Livio afterwards.
I meet him now, okay.
Okay, thanks. After the presentation. And last but not least, Jelena Cosic on Reimagining the SEE.
Feel free to come here. Yeah. Okay. Hi,
I
everybody.
wasn't part of the plan, so yes, go on.
Yeah, I have a backup. So this is not going to be a typical lightning talk. This is more of an invitation for a conversation. And this is sort of also a follow-up from the discussion that we had on the NOG panel. Because what we're interested in hearing from you today is basically the reasons that you attend the SEE meeting and what brings you here. And basically we want to start a conversation and some of the reflections on the past meetings that we organized so far, so that informs us in our decisions of planning future meetings.
So one of the reasons why I'm on stage is to also mention that Jelena has a new role within the NCC, so she's going to be responsible for coordinating the content for these meetings moving forward. Vesna, who I'm sure all of you know, used to do a really great job on this, and she will continue to support the PC in certain capacities, but Jelena will be more engaged moving forward in trying to bring more relevant content to this forum, which is why we're asking the question. And before I get questions at the mic, are we planning on stopping doing the SEE meetings? We absolutely are not. This is more about trying to find the value proposition that would keep you more engaged and come back more and more and have good reasons to tell your boss why you should travel around this lovely region attending these meetings. Jelena?
So, for those people who know me, you probably know that I love to talk about history. So I'm going to fulfill kind of that expectations again. So I just wanted to take a very brief reflection on the past 13 SEE meetings. And going all the way back to the first RIPE meeting in 1989, I wanted to say that since for about 15 years, the community has been meeting mostly in Western Europe. And after some time, so after about 15 years of doing so, it was pretty clear that these meetings are not equally accessible to all of the community and members. And that's why after some deliberations, RIPE NCC decided to come closer to this membership, and that's how the regional meetings were introduced. And the very first regional meeting was MNOG, and back in 2006. The second one that was introduced was ENOG in 2011, and the same year in September 2011, there was a very first SEE meeting in Croatia.
So, show of hands, who was in Dubrovnik for the first SEE meeting? Yes, Zoran. Yeah, Daniela was there. I know Jan, Zorz, and Desiree were there, but they're not in the room. So, yes, we did have a very nice first meeting where people came together, and it was clearly there was a need to come together and discuss. I think some of this was already touched on the NOG list discussions now.
Yeah, exactly. And these are just another overview of the past meetings, where you can see all of the different locations, how where the meeting moved from and to. One interesting thing to notice is that we never came back to the same city, except that we're for the first time, the second time in Sofia, Bulgaria. So that's an accomplishment. Yes. And I wanted to point out that when I was looking at the evolution of the meeting, one of the most striking insights for me, at least, was the way that program committee changed over the years. And I looked into the composition, or the people who volunteered to be on the PC for the first meeting, and I compared that list to the current PC. So there are a few differences that you also probably could spot easily. First thing that I put in bold is that we had 3 RIPE NCC staff members on the PC, and today we have only 1. Secondly, on the first list, you probably can recognize some names and people coming from the countries that are outside of the region. And today, the whole PC is comprised of the people from the region itself, and not only that, but we're proud that each country has its own representative. The PC members also serve an important role in their own local communities. They're important and influential figures, and a lot of them are also very involved with the IXP projects or the NOG communities as well. So we're just going straight forward to kind of opening the floor to you. Yeah.
And so the idea is whether now you go to the mic or whether during the social event, try to find us and try to talk to us about what you would like to see at the SEE meeting moving forward. We've had similar discussions at other regional meetings like MNOG, for example. And in the Middle East, there was no peering forum. So MNOG became a NOG/peering forum that attracted a lot more people and attracted a lot more attention towards that meeting. We sunset ENOG since we started these discussions, but we spinned off the Central Asia Peering Forum, again for the same reasons. Now, in this part of the world, you have peering days, so turning into a peering forum doesn't really make too much sense. But then maybe there's something else that would be attractive to you, your boss, your businesses, that you would like to have some regional attention. We heard the great work that's happening on the national level, right? How do you funnel that up? How do you take that to a regional coordination level? And then you funnel that even more towards the right meeting. So with that, with these simple questions, if anybody has thoughts now, please go to the mic. If not, we're here for the next day. There's a social, there's 2 actually, and we'd love to hear more from you. Anybody with any thoughts so far?
Or maybe I would ask, like, even more concrete question. If anybody wants to come up and say, how did you convince your boss to approve your trip to the SEE meeting? Or if you're your own boss, how did you justify this trip? So please, anyone?
Yeah,
there must be some experiences.
Yes. Well, I mean, but that's also a thing, right? What would make you willing to travel to the next SEE meeting?
Can you come to the microphone, please?
Yeah. Yes. While you're doing that, we do recognize that at the regional meetings, we usually get like 50% newcomers, right? Which I think to the point about the ease and convenience of being in the same country. However, we have 50% that do not come from the country. That means people do see value in flying for this, right? Please, name and affiliation as well, please.
I made my point, that actually Jelena was asking how did we convince our boss to bring us here, and actually, my comment there was that this question is towards the people that are not from Sofia, because Sofia is very convenient for all of us that are from Sofia. And but
would you go to SEE 14 somewhere else?
Well, I would love to, but now I would be looking for the way to convince my boss, to send
And
this.
what would convince him?
Yeah, I'm looking forward to some inspiration from the others.
Which is what we're looking forward to as well.
Yeah, okay.
Yeah, but thank you for going to the mic for that. Anyone else with thoughts? Anyone else feel that there's something missing here or something that we could be doing more? This would be useful for the PC to hear as well.
I would also like to encourage everybody else. So also the social event, when we have a couple of drinks and everything,
Yes.
people sit
So
up.
let's get a couple drinks in you guys, and then we'll hear you talking
please.
about. Oh, there was another comment. Yes. And again, this isn't meant to put anybody on the spot, but we would love to hear the feedback, and we have a lot of opportunities, as you just mentioned. Please.
Hi.
Hello.
I'm Petrova Vasileva from University of Michigan. So this is my first time here. I've been to a couple of conferences, different formats. So I can share with you what I'm missing that I used to have at other places. So first thing is, if you want to spark a discussion and to make people engage more, I think this is not a good idea. You need to have a microphone runners. So people can sit, they can enjoy, and you can just give them the microphone so they can interact.
Fair enough.
The second thing, since I just arrived, I'm not sure I grabbed the whole thing here that is going on. But the second thing is that 2 days are too short. People just will get comfortable and then they need to leave. So maybe 3 days with a little bit more presentations and breaks. Of course, the long breaks is a very good idea. I agree about that. But 3 days would be better for me personally. So that's my input.
Okay. No, thanks for that. Thank you. All feedback is useful. Thank you.
Well, this is always from ICANN. So not at my current job, but my last job I did something similar. So I wanted to share a story. And I would say the biggest reason to come to these meetings is to have access to the absolute routing experts of Europe. I mean, if you can think of yourself, whatever, you're just doing your little job at your work and things, but look in the room, these are the people that running the internet, and there's nobody in your country that knows better. So these here are the people that are the routing experts of Europe, and you can get a forum where you meet people that are more qualified. So here you can really raise your ideas, discuss them with other experts, and maybe some of your ideas survive. And that's what I did in my last job with, as a registry operator.
No, thanks for that. And like I said, we are very interested in continuing this discussion with you, but probably over some food and some drinks. So with that, we'll hand it back to you to chair the closing of the session. Thank you very much.
Yeah. Thank you, Jelena. Thank you, Hisham. Well, I'll see you all tonight at the dinner. I think the buses are leaving at 7:15, so don't be late and see you at the dinner.